So here we have in our first question, question 1 part A, we have expressed as a single fraction in its simplest form. Now notice this question never asks us to use our calculator, therefore we have to show all working. So first, applying BODMAS, we know we have to work out brackets first. So we'll have to work out this 1 over 30 plus 4 over 15 first, because this is in brackets. So I'll just come here and work that out. So I'll have 1 over 30 plus 4 over 15. We'll need to find the LCM. So the LCM between 30 and 15, well, we know 15 could go into 30 two times, and well, 30 could go into 30 once, so the LCM will just be 30. So I put 30 here, then 30 into 30 is 1, 1 multiplied by the numerator, which is 1, you get back 1, plus 15 into 30 is 2, so you take that 2 and multiply by the numerator, which is 4, so 2 by 4 is 8. So we have 8 here. So now we add the 1 and the 8, and we get 9. So we have 9 over 30. So now looking at this 9 over 30, I realize that 3 could go into 30 and 3 could also go into 9. So let's break it down. So we'll have 3 into 9 is 3, and 3 into 30 is 10. So what we'll get is 3 over 10. So now that's going to rewrite the question. So we have 1 take away 1 over 30 plus 4 over 15, of course that in brackets, which would imply we have 1 take away, and we put the answer for this 1 over 30 plus 4 over 15, which worked out to be 3 over 10. So that'll be 3 over 10. And you could go and do LCM again, put 1 over 1 and work this out. But you should know that if the denominator here is 10, I can represent this 1 as 10 over 10. So I could just do this and put 10 over 10, take away 3 over 10, because 10 over 10 is 1. And now I don't have to do any LCM. I could just say 10 take away 3, which is 7. So this would just be equal to 7 over 10. So the denominator remains 10 because here's 10 and here's 10. And we just work with the numerators, right? So 10 take away 3, which is 7. And this will be your answer, 7 over 10, because we can't break this down any further. So let's put answer is equal to 7 over 10. All right, so moving on to part B of this question 1. We have a 2-story car park has a total of 1,020 parking spaces. At 6:30 hours one morning, 1/30th of the 1,020 spaces are filled. So let's work out that. So I'll put 1/30th multiplied by the 1,020 over 1. And this will be 1/30th of 1,020. So first off, the zeros could cancel here. Now bear in mind, you can use a calculator for this. All right, so now 3 into 102. Let's see if we could go in without leaving a remainder. So 3 into 1 cannot. 3 into 10, we'll get 3. So I'll write 3 here. The remainder will be 1, so put 1 here. And now 3 into 12 is 4. So when I cancel this 3 here, I get 1. And when I cancel this 3 the 102, I get 34. So this is equal to 34. Now let's use the calculator. So if I go on the calculator and use my fraction button, being this button here, I can put 1 over 30 like this, and that's simply multiplied by 1,020 like that, press equal, and you see you get 34. So now let's keep reading. So we have during the next hour, so 1 hour away from 6:30 will be 7:30 in the morning. So during the next hour, no cars left the car park, which means we still have 34 cars in the car park. But another 4/15 of the 1,020 spaces are filled. So this here is for 6:30. And 1 hour later, we have 4/15 of the 1,020 spaces are filled. Well, a further 4/15. And again, we could cancel and work this out, or we could just use the calculator. So I put equal to, and using the calculator, 4, press the fraction button, over 15, multiply by 1,020, and we get 272. So I'll come here and put 272. So the way this is working is that at 6:30 we have 34 spaces filled. 1 hour later we have a further 272 spaces filled. Therefore, at 7:30 we'll have a total of 272 plus 34 spaces filled. So at 7:30 we have parking spaces filled would be the 34 plus the 272. So we have 34 plus 272, and we get 306. So this will be equal to 306. Now the question is asking us, determine the number of parking spaces that are not filled. So what we calculated here was the number of parking spaces that are filled at 7:30. Now they want us to determine the parking spaces that are not filled at 7:30. So we know there's a total of 1,020 spaces, and we know at 7:30 306 are filled. So the unfilled parking spaces, we just have to subtract these two numbers, right? So 1,020 take away 306. So here we have empty parking spaces at 7:30 would be equal to the 1,020 take away the 306. So that would be equal to, so we put 1,020 take away 306, and we get 714. So that would be 714 spaces are empty. Now for part C, we have, of the 120 parking spaces, 20% are on the top level. How many parking spaces are there on the top level? So that's simple. Just find 20% of 1,020. So 20%, which is 20 over 100, multiplied by 1,020 is equal to, and again, this we call it simple cancellations, cancel the 0 here, cancel the 0 here, and all we end up with is 2 times 102, which is 204. So the answer will be 204 parking spaces are on the top level. So now moving on to part D, we have some spaces are reserved for monthly paying customers. The ratio of reserved spaces to non-reserved spaces is 5:7. So on this ratio 5:7, the 5 shares would be the reserved spaces and the 7 shares would be the non-reserved spaces. So what we want to do is calculate the number of non-reserved parking spaces. So we know our total shares is equal to the 5 plus 7. And 5 plus 7 is 12, so we have 12 shares in total. And remember, the total number of parking spaces was 1,020, which means my 12 shares is equal to 1,020 parking spaces. So what we want to do is find out, how much is 1 share. And once we get what is 1 share, we could find out what is the 5 shares or the 7 shares, anything we want. So to get 1 share, I'll have to divide this side by 12. As you know, whatever you do to one side of the equal sign, you must do the same thing to the other side. So dividing this side by 12 will give us 1 share. I must divide this by 12 also. So I'll have 1 share is equal to 1,020 divided by 12. So 1,020 divided by 12 will give us 85. So we have 1 share is 85. And now remember, the non-reserved parking spaces is equivalent to the 7 shares. So 7 shares is equal to 85 times 7. So I'll just take that 85 and multiply it by 7. And I get 595. So this is equal to 595 parking spaces. So the non-reserved parking spaces is equal to 595. So moving on to part E here, we have the cost for parking at a car park is shown in the table below. So we have length of visit here. So we have under 30 minutes, more than 30 minutes, and up to 2 hours, and so on. And here we have the cost. So for part 1, we have Michaela leaves the car park at 18:30 hours and pays $9.25. So they want us to determine the earliest time she could arrive at the car park. So if we look at the money that she pays, which is $9.25, and try to find out, where that falls here. So we have under 30 minutes is free, but more than 30 minutes up to 2 hours is this price, and we see the $9.25 here. So that's more than 4 hours and up to 8 hours. So the maximum amount of time she could spend at the car park for $9.25 is 8 hours. Now remember, Michaela leaves the car park at 18:30 hours. So what we are trying to figure out is, when did she arrive? What's the earliest time she could arrive? Now if you look at the range of 4 to 8 hours, and we look at the lower end of 4 hours, arriving 4 hours before would be later than arriving 8 hours before. So if she arrived 8 hours before, that'll be the earlier time. So all we have to do is subtract the 8 hours from the 18:30 hours, and that's simple. 18 take away 8 is 10, so you get 10:30 as the answer. So we have 18:30 like this, take away the 8 hours. So this is 18 hours and 30 minutes, and this is just 8 hours and 0 minutes. So we are taking away, of course, zeros. 3 take away 0 is 3, 8 take away 8 is 0, and remain with the 1. So I have the earliest time she could arrive would be 10:30 hours. So next we have part 2, where we have Danraj bought a weekly parking ticket for $40. That week he visited the car park 5 different times. The length of time he parked his car on each occasion is given below. So we have 25 minutes, 7.5 hours, 11 hours, 8.75 hours, and 8 hours. So we want to show that Danraj saved $8.50 by buying the weekly tickets. So I just brought back the table with the length of visit and the cost. So this 25 minutes would have been free because under 30 minutes is free. So I'm going to write free here. So this was free. Then we have 7.5 hours. Where does that fall? Well, that will be more than 4 hours and up to 8 hours. So 7.5 hours is within this range, and that'll be $9.25. So here I'll put $9.25. Then next we have 11 hours. So 11 hours will fall in this range, more than 8 hours and up to 24 hours. And that will be $15. So for 11 hours, that will cost $15. Then we have 8.75 hours. Let's see where that falls. Well, it wouldn't fall here because it's more than 8 hours. So again, that will fall within here. 8 hours up to 24 hours. So that will be a further $15. And then we have 8 hours. Now notice, more than 4 hours and up to 8 hours. Here starts at more than 8 hours. So the 8 hours will fall in this range here, which is $9.25. So here we have $9.25. So now all we have to do is add up all these costs and see if the money crosses $40 or if it's under $40. If it crosses $40, then it would have been better to take the weekly parking ticket of $40. But if it's under $40, then not taking the weekly parking ticket would have been the better option. So let's see. So I'm going to have the $9.25 plus the $15 plus $15 again plus $9.25. Of course, we add in. So I have $9.25 plus $15 plus $15 again plus $9.25. And I get $48.50. So 0.5, remember, is money we're dealing with, so we need 2 decimal places. So this will be 50 cents. So we have $48.50. Now it's very clear to see that if he paid $40 for a weekly parking ticket, this crosses that amount by $8.50. So he saves $8.50 by buying the weekly parking ticket. But still, we're actually looking for it. So I was going to put money saved is equal to the $48.50. Take away $40 for the weekly parking ticket. And that will be $8.50. So moving on to question 2, part A, we have to simplify this algebraic expression. Now, we notice that, well, you have two terms in the numerator and two terms in the denominator. Therefore, we cannot cancel a term in the numerator with a term in the denominator. So this x squared here cannot cancel with this x squared down here. We'll have to find another method. Now, I notice that in the numerator, we have x squared and then have the 7x. So x is common to both terms in the numerator. Therefore, I can factorize the numerator. So I'll just put the numerator to the side like this, the x squared plus the 7x. And I know that x is common to both terms, so that will be the highest common factor. So I'll put the x like this, open brackets, divide x squared with x, or you can say x into x squared, you'll get x, plus x into 7x, the x's will cancel, and remain at 7. Close brackets. So this would be the numerator factorized. Now I could do the same thing for the denominator. But I notice that there's nothing common between the two terms in the denominator, only 1. So then what do I do here? Well, I recognize that we have x squared here, and this 49 is 7 squared. And this is a subtraction sign, so that'll be difference of 2 squares. So, looking at the denominator, we have x squared take away 49. And as I said, that'll be x squared take away 7 squared, because 7 squared is 49. And which is the difference of 2 squares? So we'd have x plus 7 in brackets multiplied by x take away 7. So now I'm just going to write over the question. We have x squared plus 7x over x squared take away 49. And this would imply, so for my numerator, I factorized my numerator and I got this as the answer, x multiplied by x plus 7. So I'm writing this for the numerator. So I have x multiplied by x plus 7 as my numerator. And then for my denominator, we factorized this and we got, x plus 7 multiplied by x take away 7. So this will be over. And for my denominator, that works out to be x plus 7 multiplied by x take away 7. Now, we notice that we have something multiplied by something in the numerator, and same thing in the denominator, something multiplied by something. Now watch this. In the numerator, I've seen the x plus 7 here, which is multiplied by the x. And in the denominator, I'm seeing that same x plus 7 was multiplied by x take away 7. Now, in this situation, we can cancel. So up here, when you had individual terms in the numerator, same thing in the denominator, remember terms are separated by plus or minus signs, you just cannot take one term and cancel it with the next term. But if I have something multiplied by something, I can use that to cancel. So essentially, this x plus 7 will cancel this x plus 7. So what you'll remain with is x in the numerator and x take away 7 on the denominator. So this would imply x over x take away 7. And this will be your answer to simplifying this expression. Now for part B, part 1, we want to find the value of r when we have x to the power 2 multiplied by x to the power 6 is equal to x to the power r. So I'm just going to write that over. X to the power 2 multiplied by x to the power 6 is equal to x to the power of r. And we know the x is called the base, and the 2 here will be the power or the index. And we know anytime the bases are the same, see x and x here, bases are the same, and we are multiplying, we'll simply add the powers. So this would imply x to the power 2 plus 6 is equal to x to the power of r, and 2 plus 6 is 8. So again, this would imply that we have x to the power of 8 is equal to x to the power of r. And now, since the two bases are the same and we have an equal sign, then that has to mean that, 8 is equal to r, or you could say r is equal to 8. So this implies that r is equal to 8. And this will be your answer. You have found the value of r. So moving on to question 2, part B, part 2, we want to find the value of s when s cubed is equal to 8. So if s cubed is equal to 8, it means s is equal to the cube root of 8. And we know 2 by 2 is 4, and 4 by 2 is 8. So the cube root of 8 will be 2. But we can use the calculator and solve it. So on my calculator, the cube root button is the second function of the x cube button. So I'll press second function first, then the x cube. You see the cube root comes up. Then I put 8, press equal, and I get 2. So therefore, that would imply that s is equal to 2. So now moving on to question 2 part C, we have the diagrams below show a triangle and a quadrilateral. So this is my triangle, and a quadrilateral is a 4-sided shape, so this is the quadrilateral. They say all angles are in degrees and are written in terms of A and OB. Now we know the interior angles of a triangle must add up to 180 degrees, and also the interior angles of any quadrilateral would add up to 360 degrees. So that for part 1, for the triangle, show that 2A plus 5B is equal to 171. So the only information we have here are the interior angles of the triangle, and we know they're supposed to add up to 180 degrees. So let's do that. So I'll have the A plus 2B plus the 3B plus the A plus 9. And that's supposed to add up to 180 degrees. Now, what we could do is bring our like terms together. Now, I know my A is looking like a 9. So I'll just shorten this here so it make it look like a A, and also this one so it looks like a A. So now what we'll have to do is bring our like terms together. So I have the A's here, I have the B's here, and I have this 9 as a constant, put this 180 as a constant as well. So we have the A with this positive A. Then we have the positive 2B with this positive 3B. And of course we have the positive 9 with this 180, positive 180. So writing the like terms together, remember the sign in front of the number is part of the number. So we have positive A with positive A. Then we have positive 2B with positive 3B. And now what I'll do is put the equal sign here, put the 180. And what I'll do, I'll transfer this positive 9 across the equal sign and we'll turn to negative 9. So I'll have negative 9 here. So now let's simplify. So A plus A is 2A. So we get 2A here. Then we have positive 2B plus 3B. That's positive 5B. And that'll be equal to, and of course 180 take away 9 is 171. So we'll have 171. And that's exactly what they have here. 2A plus 5B is equal to 171. Now, part 2 of the question they have for the quadrilateral, they want to show that 7A plus 8B is equal to 342. So again, same thing. All we have is the interior angles of the quadrilateral, and we know they're supposed to add up to 360. So I'm going to write 6A plus this 3A plus 2B plus this 3B take away 2A plus this 18 plus 3B. And that's supposed to be equal to, well, it's supposed to add up to 360 degrees. So again, I'll highlight my like terms, bring them together, simplify, and see what we get. So we have positive 6A here, we have positive 3A here, and here we have negative 2A. And that's it for the A's. Then I have positive 2B here, positive 3B, and positive 3B here again. And then for my constants, I have positive 18 and this 360, positive 360. So for my like terms, I have the 6A plus this 3A, take away this 2A. Then for the B's, we have positive 2B plus 3B plus this 3B here. And then all remaining now is the constants. So I'll transfer this positive 18 across the equal sign and to negative 18. So I'll put this equal to a 360 and transfer the positive 18 across and turn to negative 18. And now I'll simplify. So we have 6A plus 3A, that's 9A, and 9A take away 2A. So 9 take away 2 is 7. So we have 7A. Then we have 2B plus 3B, that's 5B. And 5B plus 3B again is 8B, positive 8B. So that's plus 8B. And that's equal to 360 take away 18 is 342. And this is exactly what they have here. And now this part 3 is the last part of question 2. So here we want to solve the pair of simultaneous equations in part 1 and part 2 to find the values of A and B. Of course, I want us to show all working. So let's go back. So in part 1, our equation is 2A plus 5B is equal to 171. Of course, we show that here. So here we have the equation from part 1, and we'll call that equation 1. Now going back to part 2, this is our equation here. 7A plus 8B is equal to 342. And we show that here. So this is our equation from part 2, and we'll call that equation 2. So now for this pair of simultaneous equations, we have options. We could use the elimination method. We could use the substitution method. We could even use matrices. All right, so I'm going to choose the elimination method to use here. So it's obvious that with the 2A and the 7A, I cannot eliminate the A as is. And with the 5B and the 8B, I cannot eliminate the B. Put it like this. So what I have to do is multiply the equations by a number so that I can either add or subtract to get rid of one of the variables being A and B. So what I'm going to do is say equation 1 multiply by, and I'm going to multiply by the 7 here. So I'm going to multiply everything in equation 1 by 7. So I'm going to have 2 by 7, and I'm going to get 14A. I'm going to have 5B by 7, and 5 7s are 35, so that's 35B. I'm going to put equal, and 171 by 7. So 171 multiplied by 7 is equal to 1,197. So we get 1,197. Then for equation 2, I'm going to multiply it by this number here, this 2. So I'm going to have equation 2 multiplied by 2. So everything in equation 2, I'm going to multiply by 2. So 2 by 7A is 14A. 2 by 8B, 2 by 8 is 16, so 16B. And 342 by 2. So I'm going to have 342 multiplied by 2. And I'll get 684. So that's 684. Now, notice we have 14A here and 14A. Both of them positive. So if I subtract, I will get 0 and eliminate the variable A. So I'm going to put my subtraction signs here. So now 14A take away 14A is 0. 0 is nothing, so you don't have to write anything. And now you'll say 35B take away 16B. So that's really working out 35 take away 16. So 35 take away 16 is equal to 19. So that'll give us positive 19B is equal to, and now we have this 1,197 take away 684. So we have 1,197 take away 684, and that's equal to 513. So I'll have 513. So now we have 19B is equal to 513. So we transfer the 19 across. The operation between 19 and B is multiplication. So we transfer it across into division. So we'll have B is equal to 513 divided by 19. So B is equal to, so we'll take that 513 and divide it by 19. And we get 27. So B is equal to 27. So now that we know that B is equal to 27, let's read these equations. 2A means 2 multiplied by A, plus 5B means 5 multiplied by B is equal to 171. So if I know the value of B, I can just multiply this 5 by the value of B, and I'll get a number here. And the only variable, the only thing missing would be the A, which I can solve for. Same thing down here. 7A means 7 multiplied by A, which I don't know A, but the 8B means 8 multiplied by B. and I know the value of b. So looking at the two equations, I'm just looking for one of the better numbers, and equation 1 looks better because the number is smaller, so I'll go with equation 1. So I'm going to substitute b is equal to 27 into equation 1. So equation 1 reads, that's this 2a plus 5b is equal to 171. So 2a plus 5b is equal to 171. So again, we do know the value of a. That's what we're trying to find here now. So we have 2a plus 5b, and 5b means 5 multiplied by b. So we have 5 multiplied by 27 because b is equal to 27 is equal to 171. So we'll have 2a plus, and we work out what is 5 multiplied by 27, and we get 135. So we have 135 here is equal to 171. So now we just transfer this 135, this positive 135 across the equal sign, and we'll turn to negative 135. So we have 2a is equal to 171, take away 135. So 171 take away 135 is equal to 36. So we're going to have 2a is equal to 36. And again, the 2 is being multiplied by the a, so we transfer the 2 across. The operation will change to division, the opposite of multiplication. So we'll have a is equal to 36 divided by 2. So 36 divided by 2 will be 18. So a will be equal to 18. So we just come here and write the answers. So we have a is equal to 18. And we have b is equal to 27. So here we have question 3 part A. We have in triangle ABC, AC is equal to 8 centimeters and BC is equal to 5 centimeters. Now let's say using a ruler and compass only, construct triangle ABC. The line AB has been drawn for you. Now, I want to address this point that the line AB has been drawn for us. Now, I am on the computer. I would have cropped the picture of the line AB and pasted it onto the whiteboard. Therefore, the length of the line AB on the computer would be different from the length of the line AB on the actual past paper. So when I construct the triangle ABC here on the computer, it's not going to be the same size as the triangle ABC when you construct it on the actual past paper. So I just want to make that clear. So if they ask us to measure any angle or anything like that, you're not going to get the same answer as if it did it on the actual past paper. But the method that I'm going to use is going to be the same, and you're going to see all the steps as to how to get the right answer. So because we have the line AB already drawn for us, we have the line segment AC now. This is construction. So you're starting at A, ending at C, and that line has to be 8 centimeters. So therefore, from A to some point C has to be 8 centimeters. So here I have my ruler and compass. I'm going to take the compass, place the point of the compass on the 0 of the ruler, and I'm going to open that out to 8 centimeters. So my compass is opened out to 8 centimeters. Let's move the ruler. I'm going to take the compass point and place it on the point A. And I'm going to make an arc using a light line. Then I'm going to look at the line segment BC, which means you're starting at B and ending at C, and that line segment is 5 centimeters. So I'm going to take my ruler again. I'm going to take my compass, place the point at the 0 on the ruler, and I'm going to open the compass out to 5 centimeters. Then I'm going to take the compass point, place it on B, and I'm going to make an arc to intersect this arc here. Now, the point where these two arcs intersect would be the point C. So now, all I have to do is draw a straight line from A and connect it to C, and draw a straight line from B and connect it to C, and that will be my triangle ABC. So I'll move my compass, and of course, while I'm constructing, I'm using light lines. So what I can do is just draw a straight line straight through C, like that. And then from B, I make this light line straight through C again, like this. And now this will be my triangle ABC. And once I'm satisfied with the diagram, I can darken the light lines. So I'm just darkening from A to C and from C to B. And this would be my answer. Now for part 2 of the question, we have measure and state the value of the angle BAC. So we know the angle is located at the letter in the middle anytime we use 3 letters to represent the angle. So BA is going to be an arm of the angle and AC is going to be the other arm of the angle. So let's go. BA is one arm and then AC is the other arm. Therefore, the angle is located at A. Therefore, we want to measure this angle here. So again, BA, that's B to A, and then A to C, A to C. The angle is located at A, the letter in the middle. So here I have my protractor. I'm going to line up the center of the protractor with the arm of the angle AB. And now this arm of the angle AB will be my 0 degrees. So I look on the scale, the outside scale and the inside scale, and see where the 0 degrees lines up with the arm of the angle AB. And we've seen that will be the outside scale. The 0 is here on the arm of the angle AB. So now I go all the way around from the arm of the angle AB to the arm of the angle AC. So if we go all the way around like this, we see we are lining up with about 37.5. If I use the magnifying glass, let's see. So here we'll have 30. We have 31, 32, 33, 34, 35. And then here's 36. And 37 will be somewhere here that the line is kind of blocking. And this next stroke here will be 38 degrees. So it's between, because watch, 38 here, then here will be 39, then 40. So this line here is 38 degrees. All right, so it's a little under 38 degrees. So approximately 37.5. So angle BAC is equal to 37.5 degrees. Now, I'd just like to remind you again that if you're doing this question on the actual past paper, the exact copy of the past paper, you would not get this answer because my length of AB here would be different from the length of AB on the actual past paper, which would affect the angle at BAC. But the steps that I've taken to actually do the question would be same. So once you have the actual past paper, just do the same steps, measure the angle, and whichever angle this line falls on, you just read it off and state the answer. So now we're moving on to part B of the question. We have the diagram below shows an equilateral triangle. We have FGH. So FG to H is an equilateral triangle, which means the length of all the sides are equal. So if here's 13, then here's also 13, and here's also 13. Let's put that in. So here's also 13 centimeters, and here's also 13 centimeters. So we have FGH, whose base is 13 centimeters, so we saw that. And its height is H. So H here is the height of the triangle. And as we know, height and base of a triangle must be at right angles to each other. And now what they want us to do is calculate the value of H, which means let's find the height of the equilateral triangle. So what we could do here is we could split this equilateral triangle up into the 2 equal right angle triangles. Or I could say the right angle triangles would be congruent because they would be exactly the same. So here I have one side of the equilateral triangle. So this would be H on top here. Here will be G. And this would be my height H. Of course, the length of the side is 13 centimeters. And now think about this. This line here will cut the base in half. So the length of F to G is 13 centimeters. Half of 13 is 6.5. Therefore, the length down here would be 6.5. So here's going to be 6.5 centimeters. And that's because this height split this base in half. So what we have is 6.5 centimeters here and 6.5 centimeters here. 2 equal right angle triangles. So now we have a right angle triangle. We have 2 sides given and 1 side missing. And that tells us we have to use Pythagoras' theorem to find the missing side. So first we're going to identify what is the hypotenuse. which is the longest side on a right angle triangle, or the side opposite the right angle. So you see I drew a line from the right angle, it touches this side, and therefore HG is the hypotenuse of the triangle. So I'm going to put hypotenuse here. Now Pythagoras' theorem states that the square on the hypotenuse is equal to the sum of the squares on the other two sides, which would mean 13 squared, because that's the square on the hypotenuse first, is equal to the sum, which means to add, of the squares on the other two sides. And the other two sides are h and 6.5. So we're going to square the h and add it to the square of 6.5. So now what I could do is transfer this positive 6.5 squared across the equal sign, and it will change from positive to negative. So we have 13 squared, take away 6.5 squared is equal to h squared. And now I could work that out on the calculator by saying 13, press the x squared button to square it, take away 6.5, press the x squared button to square it, press equal, and we get 126.75. So I'm going to have 126.75 is equal to h squared. And if I want to find h, I'll have to find the square root of 126.75. So I'll go to my calculator, and for me I have to press second function and then the x squared button for the square root to come up. And then I put in that 126.75. Press equal. Now this answer is not exact, and unless the question tells you otherwise, you have to write these answers that are not exact to three significant figures. So 1, 2, 3. The 2 is the third significant figure. After it is a 5, therefore 2 goes up by 1 and turns to 3. So 11.3. So I'm going to have h is equal to 11.3 centimeters. So here I'm just going to state my answer. H is equal to 11.3 centimeters. So now moving on to part C, we have the diagram below shows three triangles, P, Q, and R. So here we have P, we have Q, and we have R. Triangles Q and R are images of triangle P. Therefore, triangle P is my original triangle, the object, and these two are images. Alright, so we have triangles Q and R are images of triangle P after it undergoes a double transformation. So here they want us to describe fully the single transformation that maps triangle P onto triangle R. So P is the object, R is the image. Now if you're looking at P and R, we've seen that P and R are looking exactly the same size, it's in the same orientation, and anytime we have same size and same orientation, we think translation, which is a slide. So let's see how triangle P has been translated horizontally and vertically. So we could choose any point. We could choose this point on top here. We're going across 1, 2. So that's 2 on the horizontal, and 1, 2, 3, 4, and 4 on the vertical. We could check the other points. Let's check this one here. So object, image, 1, 2. That's 2 on the horizontal, and 1, 2, 3, 4. 4 on the vertical. We could check this point here as well. Object, image, 1, 2, and then up, 1, 2, 3, 4. So we know going to the right horizontally is a positive number. If you was going to the left horizontally, that will be negative. And going up is positive for the y. If I was going down, that would be negative for the y. So my answer here would be a translation with translation vector. And the translation vector, I place the x component at the top and the y component at the bottom. Now the x component is the horizontal shift and the y component is the vertical shift. As we said, the horizontal shift was positive and positive 2. And the vertical shift was going up by 4, which would be positive 4. Now for part 2, we want to do the same thing. We want to describe fully the single transformation that maps triangle R onto triangle Q. So we want triangle R as the object, mapping to triangle Q as the image. Now when looking at these two triangles, we've seen that they are not in the same orientation. So it cannot be a translation. But what I notice about R and Q, it's laterally inverted. And anytime I see lateral inversion, that tells me it's a reflection. So now I have to figure out where's the mirror line. And we know the distance between the object and the mirror line must be the same as the distance between the image and the mirror line. And of course, the line connecting the object to the image must be at right angles to the mirror line. So if I were to draw some lines connecting the image to the object, we are seeing that all the lines connecting the image to the object would be at right angles to a vertical line. So now let's find what is half of these lines. So on the top one here, we have 1, 2, 3, 4 blocks. So halfway will be 2 blocks. That'll be here. Let's look at this one. 1, 2, 3, 4 blocks again. So halfway will be 2 blocks. This one will be 1, 2, 3, 4, 5, 6. Halfway will be 3 blocks. So 1, 2, 3. Therefore, this would be our mirror line. All right, this will be my mirror line. Okay, and this mirror line, look at where it touches the x-axis. This is 0 here, this is 2. So halfway between 0 and 2 will be 1. So this mirror line touches the x-axis at 1. Therefore, the equation of the mirror line is x is equal to 1. So mirror line, x is equal to 1. So what we have here is a reflection in the line x is equal to 1. So for my answer, I'm going to put reflection in the line x is equal to 1. Now this question 4 is a functions question. So let's read. We have considered the following functions. We have f of x is equal to 2 take away 5x and h of x is equal to 5 to the power of x. For part A, they want us to calculate the value of f of 4. So that's pretty simple. So if f of x is equal to 2 take away 5x, then f of 4, as you can see, we are replacing the x here with 4. Therefore, we have to replace the x here with 4. So this is going to be equal to 2 take away 5 times 4. Because 5x, this 5x here means 5 multiplied by x. So we're going to have 5 multiplied by 4, which is 20. So we're going to have f of 4 is equal to 2 take away 20. And 2 take away 20 is equal to negative 18. Next, for part A, part 2, they want us to calculate the value of h of 0. Now we have h of x is equal to 5 to the power of x. So I'll write that. H of x is equal to 5 to the power of x. And same thing again, we want to find h of 0. So we are replacing the x with 0. Therefore, we have to replace the x here with 0. So we're going to have 5 to the power of 0. And we know from the laws of indices, any number to the power of 0 is equal to 1. So you're going to have h of 0 is equal to 1. Now moving on to part 3 of part A, we have a composite function. We want to find f h of negative 2. So the first thing we have to do is work out what is h of negative 2. So I'm going to write h of x is equal to 5 to the power of x. Therefore, h of negative 2 will be equal to 5 to the power of negative 2. So remember, replacing the x with negative 2, therefore the x here gets replaced with negative 2. Now we could use the calculator in paper 2 to work out the value of 5 to the power of negative 2. But I'm going to use the laws of indices here. So we have the negative power. We know that will be 1 over 5 to the power positive 2. And 5 to the power 2, that's 5 squared, that'll be 25. So we have 1 over 25. Now I'd also like to show this on the calculator as well. So we have 5, we can use the yx button, yx, and we put negative 2, so that's 5 to the power negative 2, and we see we get 0.04. And now if I press this fraction button here, we can see that 0.04 is 1 over 25. Press it back. 0.04. So you can use the calculator to get your value here. So you can write the answer either as a decimal 0.04 or as a fraction 1 over 25. So this will be h of negative 2. So now if we want to get f h of negative 2, that'll be equal to f of 1 over 25. And that's because the h of negative 2 worked out to be 1 over 25. So I'm replacing the h of negative 2 with this 1 over 25. So now we have to look at the function f, which is 2 take away 5x. So this will be equal to 2 take away 5 multiplied by x, and I'm replacing the x with this 1 over 25. So 1 over 25. Now we should know this is 5 over 1 multiplied by 1 over 25. I'll just come right here and work that out. 5 over 1 multiplied by 1 over 25. I mean, I could have worked this out right here, but I just want to show it so everything is clear. So, 5 into 5 is 1, and 5 into 25 is 5. And if we multiply across, 1 by 1 is 1, and 1 by 5 is 5. So this 5 multiplied by 1 over 25 works out to be 1/5. So this will be equal to 2 take away 1/5. Now you can go to the calculator and use the fraction button to work this out, but this is simple. 2 take away 1/5. So you're going to remain with 1 and 4/5. So I'm just going to put the answer as 1 and 4/5. But I'll go on the calculator and work this out and show you. So what I'll type into the calculator is 2 take away. I'll press the 1. This is the fraction button, so that'll be over. And press the 5, so that's 1 over 5. Press equal. And you see you get 1 and 4/5. Now moving on to question 4 part B, we want to find f inverse x. So we're dealing with the function f of x. So to find the inverse of any function, we're going to let y be equal to the function. So the first thing we'll do is say let y be equal to f of x. So therefore, y is equal to 2 take away 5x, because that's what f of x is equal to. The second step would be to interchange the x and y. So I have this little symbol here, which means to interchange x and y. So wherever I see y, you put x, and wherever I see x, you put y. So y is here, we're going to put x. Put back the 2, take away 5 times x, and with the x's, you're going to put y. And the last step, the third step, would be to transpose for y. So I'm going to transpose for y here. So I'm just going to write back the x is equal to the 2 take away 5y. Transposing for y means we want this y by itself. So I have to transfer the 2 and this negative 5 across the equal sign. So first we're going to start with the positive 2. And when we transfer this positive 2 across the equal sign, the sign front end will change from positive to negative. So I'm going to have x take away 2 is equal to negative 5y. So you see, from positive 2 to negative 2, the 2 was transferred across the equal sign. Now, this negative 5 is being multiplied by the y. So when I transfer the negative 5 across the equal sign, the operation will change from multiplication to division. So what will happen is that the negative 5 will go under the x take away 2. So that will read x take away 2 divided by negative 5 is equal to y. So we see that we transfer the negative 5 across the equal sign. The operation changed from multiplication to division. So no sign change. This remains negative. What took place is multiplication to division. So if negative 5 went under the x take away 2. And now that we have y by itself, we have transposed for y. Therefore, this here would be our inverse function. So f inverse x is equal to x take away 2 divided by negative 5. So moving on to question 4 part C, we want to work out what's the composite function f of x. Of course, we want it in the form a plus bx, and we want to determine the values of a and b. So again, we're just dealing with the function f of x. So I'm going to write f of x is equal to, and I'm just going to put some brackets here. So f of x like this. So what I'm saying is, first I want to replace this f of x with the 2 take away 5x, because this is what f of x is equal to. So this is going to be equal to f, and put the brackets, and 2 take away 5x. 2 take away 5x. Close brackets. So now I want to work out f of 2 take away 5x. Now remember, this x here in the function is your input. So wherever your input is here, you put in that same input where the x is here. So now for this function f, my input is 2 take away 5x. Therefore, when I look at where the input has to go, I need to replace this x here with 2 take away 5x. So I'm going to have 2 take away 5x, 2 take away 5, and that x is going to be the input, and the input here now is again 2 take away 5x. 2 take away 5x. Close brackets. So now we'll just expand and simplify. So we'll have 2. We're going to multiply negative 5 by positive 2, and we get negative 10. And then we're going to multiply negative 5 by negative 5x, which will give us a negative by negatives are positive, so that's positive 25x. So positive 25x. Now we can see here that, the 2 and the negative 10 are our like terms, and this 25x by itself. So 2 take away 10 is negative 8. So we're going to have negative 8 plus 25x. And that will be what f of x is equal to. Now remember, they want us to determine the values of a and b. So if we look and we put this form a plus bx, just going to put that here. f of x is equal to a plus bx. We can see that the a lines up with the negative 8. We see the x lines up with the x here, and therefore the b lines up with 25. That means a is equal to negative 8 and b is equal to 25. So I'm just going to put, therefore, a is equal to negative 8 and b is equal to 25. So here in question 5, we have the mass m in kilograms of 120 newborns at a hospital is recorded in the table below. So here we have the mass in kilograms. So this m here is the mass, and what this class interval is saying is that the mass here is greater than 2.6 kilograms and less than or equal to 3.5 kilograms. So this would be a lower class limit, and this would be an upper class limit. And of course, here we have the frequency f. So we have 7 newborns will be within this class interval, 18 newborns will be within this class interval, and so on. Now here for part A, part 1, we want to state the modal class. So that will be the class interval that has the highest frequency. So we look at the frequency column, the highest frequency is 30. Therefore, this class interval would be the modal class. The mass greater than 4.4 kilograms and less than or equal to 5.3 kilograms. So my modal class is 4.4 is less than the mass, which is less than or equal to 5.3 kilograms. Now moving on to part A, part 2, we have to complete the table below and calculate an estimate of the mean mass of the 120 newborns. Now the fact that they tell you that you have 120 newborns, it means if you add up the frequency, you should get 120. So sigma f should be 120. So I'm just going to do that on the calculator to make sure. So we have 7 plus 18 plus 30 plus 29 plus 28 plus 8 equal 120. So we see that the sum of all the frequencies would be 120, which is sigma f. And the reason we need sigma f is because we know the mean is sigma xf divided by sigma f. So that means we have to add up all the numbers in this xf column to get sigma xf and divide it by sigma f to get the mean. Now we can see this table have some stuff missing. We have stuff missing here in the sigma f column, and we have stuff missing here in the midpoint column. So let's fill out the midpoint first. Now what we could do is add the lower class limit to the upper class limit and divide by 2, and that will give us our midpoint. So you can just run a check and make sure that the midpoint is correct here. So we have 2.6 plus 3.5, press equal, and then divide by 2. And you can see that we got that 3.05. So we just continue with that, add the 5.3 to the 6.2, and divide by 2. So we'll have 5.3 plus 6.2, press equal, and then divide by 2. And we get 5.75. So we're going to have here 5.75. Then we'll add the 7.1 plus the 8, press equal, and then divide that by 2, divided by 2, and we get our midpoint, 7.55. So we have 7.55. And now remember, this column is x multiplied by f. Midpoint multiplied by frequency will give you the answers for this column. So to get what's missing here, we just have to multiply the midpoint of 5.75 by the frequency 29. So we're going to have 5.75 multiplied by 29, and we get 166.75. So I'm going to write 166.75. And then to get what's missing here, I'll multiply this midpoint, 7.55, by the frequency 8, so x by f, and that will give me the answer for here. So we have 7.55 multiplied by 8, and that will give you 60.4. So I'll have 60.4. So we have filled out the table, but remember we want to calculate the mean mass. So we need to get what is sigma xf, which means to add up all the numbers in this xf column. So I'm going to have sigma xf is equal to, and I'm going to add up 21.35 plus 71.1 plus 145.5 plus 166.75 plus 186.2 plus 60.4. Press equal, and we get 651.3. So we have 651.3. So now the mean is equal to sigma xf divided by sigma f, which is 651.3 divided by 120. So we're going to type in on the calculator 651.3 divided by 120. Press equal, and we get 5.4275. Now, seeing that the mass here was given to 1 decimal place, and the midpoint, which is the midpoint of the mass, was given to 2 decimal place, I would approximate the mean mass to 2 decimal places. So we're going to have the mean is equal to, and if we look here, we have first decimal place, second decimal place is this 2. After the 2 is a 7, therefore this 2 goes up by 1, and I have 5.43 kilograms. So I'm going to write 5.43 kilograms as my mean. So now for part 3 of the question, we have one newborn is chosen at random from the hospital. Find the probability that the newborn has a mass greater than 5.3 kilograms. So looking back at the table that we filled out, we have our mass here. We've seen this 5.3 kilograms. We've seen it here and also here. So we have to read this class interval properly. M is the mass, and here we're saying that the mass is less than or equal to 5.3. So that's not greater than 5.3. Here, it's less than or equal to 5.3. But in this class interval, we have the mass is greater than 5.3. So from this class interval and down, we'll have the mass being greater than 5.3. So remember, a total number of newborns was 120, which was sigma f. which means the number of elements in our sample space is 120, because that's the total number of newborns. So now all you have to do is calculate how many newborns has a mass greater than 5.3. And the frequency will give us the number of newborns. So from here, we starting from this class interval, go down. So that's 29 plus 28 plus 8. So the number of elements in a set, mass greater than 5.3 kilograms, is going to be equal to 29 plus 28 plus 8, which is equal to, all right, 29 plus 28 plus 8, and that's 65. So here I'm going to have 65. So now the probability of a newborn having a mass greater than 5.3 kilograms is equal to the number of elements in a set, mass greater than 5.3, over the total number of newborns, which is the total number of elements in a sample space. So we're going to have 65 divided by 120, and that will be equal to, so we're going to type in 65 divided by 120. So we get 0.541 and so on. So the three significant figures, we stop at the 1. After the 1 is a 6, so you have 0.542. So that's 0.542. Now we could also break down this fraction into its lowest terms. And we can do that using the calculator as well. Alright, so we just use the fraction button and put 65 fraction button over 120, press equal, and you see the calculator breaks it down to its lowest terms, which is 13 over 24. So your answer could also be 13 over 24. So whether you want to write it as a decimal or a fraction, that's okay. So now for part B, part 1, we want to complete the cumulative frequency table shown below. So we have the mass here. Mass is less than or equal to 3.5. Mass is less than or equal to 4.4, and so on. And then we have the cumulative frequency. We have 3 of them filled out first. We have to fill out the rest. Now I just brought up the table next to this table so that we can see the information that we need to fill out the cumulative frequency. Now notice your upper class limits is 3.5, 4.4, 5.3, 6.2, 7.1, and 8. Notice you are seeing the upper class limits here. And your first frequency is 7, therefore that's your first cumulative frequency. And then you're going to say 7 plus 18, and that will give you 25. And then 25 plus 30, and that will give you 55. So to continue, you have to put 55 plus 29. So 55 plus 29, that will give you 84. So I'm going to write 84 here. Then I'm going to have 84 plus 28. So 84 plus 28, and that's equal to 112. So 112. Then I'm going to have 112 plus 8. And that's obvious. 112 plus 8 is 120. Now notice your last cumulative frequency is the same as sigma f. It must always be like that. Sigma f and your last cumulative frequency must always be the same number. So moving on to question B, part 2, we have on the grid below, draw the cumulative frequency curve to show the information in the table in B, part 1. So remember, this is the table for B, part 1. So this is the information that we need to draw the cumulative frequency curve. So I'm just going to put the table here so that we can see the information that we need to draw the cumulative frequency curve. Now notice they have 1, 2, 3 points plotted for us. Notice this point here is plotted on 3.5. Therefore, we are using the upper class limits on the x-axis with the cumulative frequency on the y-axis. Now notice you're not seeing the information for when the mass is 0, but to close off the cumulative frequency curve, they plotted 0 with 2.5. So we have this point here, which is this information here, 3.5 with 7. We have this point plotted here, which should be 4.4 with 25. Now it's important to know what each little block represents on each axis so that you can figure out how to plot these points. So on the x-axis, we are going up by 1. So we have 10 blocks for every 1 unit. So we're going to have each block on the x-axis is equal to the unit, which is going up by 1 unit, over the number of blocks, which is 10. Because we have 10 of the smallest blocks between every unit here. And 1 divided by 10 is 0.1. Therefore, on the x-axis, each little block will be 0.1. So when we come here now, we are 3.5, 3.6, 3.7, 3.8, 3.9, 4, 4.1, 4.2, 4.3, 4.4. And that's why 4.4 is here. Now on the y-axis, we are going up by 10 units, and the number of blocks is 5. So each block on the y-axis is equal to the unit, which is 10, over the number of blocks, which is 5, and that will be 2. Therefore, every little block on the y-axis would be 2. So when you come here now, we have 20, 22, 24, and here's 26. So between 26 and 24 will be 25. And that's why this x here is in the middle of 24 and 26 for it to be 25. So now that we have established that, let's plot the rest of points. So now we have to plot 5.3 on the x-axis with 55 on the y-axis. So if you come down here, 4.5, here will be 5, and here will be 5.5. So from 5, 5.3 will be 5.1, 5.2, 5.3. And we're going all the way up to 55. So let's come back to this solid line here, go all the way up to 55. So 50 here, 52, 54, and 55 is in the middle. So I'll stop at the 54 here, and let's go across to 5.3 now. So 5.1, 5.2, 5.3. And now 55 will be in the middle of this block here, so this was my point. So now we're plotting 6.2 on the x-axis with 84 on the y-axis. So here's 55, here will be 6, see, 6.5, so here's 6. So 6.1, 6.2. So I'll stick to this line here with 6 and go all the way up to 84. So go all the way up to 80 here. So 82, 84, and now I'm going to come across to 6.2, right? So 6.1, 6.2. And now we're going to plot the 7.1 with the 112. So 7.1 on the x-axis. So here's 6.5. So here will be 7. So 7.1 will be right here. So let's stick to the line with 7 and go all the way up to 112. So going all the way up, 90, 100, 110. So 112 will be here, right here, 112. And I'm going across to 7.1, which is right here. And the last one will be to plot 8 on the x-axis with 120 on the y. So we have 8 here, see 7.5, so here's 8. And I go all the way up to its top, which is 120. So here we can see our S-shaped curve. We just have to connect these points using freehand, making a smooth curve, and that will be our cumulative frequency curve. All right, so that's the best I could do on the computer. All right, this will be our cumulative frequency curve. And now for the last question, which is B part 3, they want us to use the diagram to find an estimate for the median mass of the newborns. All right, so I just brought back the diagram so that we can use it to find the median. Now remember, we have 120 newborns. That means sigma F is 120, which implies that N, for formula for the median, would be 120. So our median, which is our second quartile, Q2, is equal to a half of the nth term. And we have 120 terms. So that's a half of 120. And a half of 120 is 60, so it's the 60th term. So we just have to come here on the cumulative frequency, find 60 on the cumulative frequency, draw a line across where it touches the curve, bring the line down, and that will be the median. So you can see we have a solid line where the 60 is, so we're just going to bring that across. It touches the curve right here, and we're going to bring that line down. And this would give us the median. Now remember, on the x-axis, each little block was 0.1, and this is just one little block away from 5.5, which means this is 5.4. So therefore, median will be 5.4 kilograms. And now just remember, when you're drawing these lines on your graph to estimate your answers, you want them to be dotted lines. So I'm just going to make it dotted. All right, so dotted lines to estimate answers off of your graph. Now in this question, we want to use pi as 22/7. So we have the diagram below shows a hemispherical bowl and a cylindrical tin. The diameter of the cylindrical tin is 12 centimeters. So we've seen that here. This is the cylindrical tin. Diameter is 12 centimeters. The height is 17 centimeters. So this is the height of the cylinder here. And the radius of the bowl is r. So this is the bowl, and this is the radius here being r. Now for A, part 1, we want to show that the volume of the cylindrical tin is 1,923 centimeters cubed, correct to 4 significant figures. Now we know this cylinder is what you call a prism, and the volume of any prism is the cross-sectional area multiplied by the height. And we have a circle at the top, and opposite to the top is the bottom, and we have the same circle. So once we have the same face on opposite ends of a solid, that would make it a prism. And that same face on the opposite ends would be the cross-section. And the distance between the two same faces would be the height of the prism. So essentially, the volume of a cylinder would be to find the area of the circle and multiply it by the height, which is the 17 centimeters. So the volume of a cylinder is going to be equal to the area of the circle times the height. So that's going to come up here, volume of cylinder is equal to pi r squared, which is the area of the circle, multiplied by the height of the prism. So pi is 22/7. Multiplied by r squared, and the radius now, here they give us the diameter, which is 12, and you know the radius is half the diameter, so the radius will be 6. So we have 6 squared multiplied by the height, which is 17. So I'm just going to put notes. The diameter was equal to 12 centimeters. Therefore, the radius was equal to 12 divided by 2, which is 6 centimeters. So now we can work all this out on the calculator, all right, because this is a paper 2 question, so everything could be done on the calculator. Okay, so here I have my calculator. For the fraction, I could put 22. This is the fraction button here for over, so over 7. Then we multiply by 6. We're going to square it by pressing the x squared button. So that's your radius squared. And multiply by the height, which is the 17. And we just press equal. And this is 1,923 and 3/7. Now to convert this mixed number to a decimal, we just start to press the fraction button like this. And you see, we get it as a decimal. Now they say they want it to 4 significant figures. So 1, 2, 3, 4, stop at the 3. After the 3 is a 4, therefore the 3 remains the same and everything behind it turns to zeros. But everything behind it is after the decimal point, so those zeros would not matter. So the answer would just be 1,923 centimeters cubed. So we'll have 1,923 centimeters cubed. Now moving on to part A, part 2, we have the bowl is completely filled with soup. When all the soup is poured into the empty cylindrical tin, 90% of the volume of the tin is filled. calculate the radius of the bowl. So looking at the shapes, the bowl is half of a sphere. That's why they gave us the volume V of a sphere with radius R is V is equal to 4/3 pi R cube. So this is the volume of a whole sphere. But what we have here is half of a sphere. So the volume of this bowl will be half of 4/3 pi R cube. So I'll just put volume of bowl is equal to half multiplied by 4/3 pi R cube. So we can see that the 2 here will cancel with the 4. 2 into 2, 1, 2 into 4, 2. So let's do that. 2 into 2, 1, 2 into 4, 2. So you get 1 here and 2 here. So 1 by 2 is 2 and 1 by 3 is 3. So we get 2/3. All right, so 1 by 2 is 2 for the numerator. 1 by 3 is 3 for the denominator. So 2/3 pi R cube. And this will be our volume of the bowl. Now, what they are saying here is that the volume of the bowl is equal to 90% of the volume of the cylindrical tin. Now remember, on the previous question, we worked out the volume of the cylinder. So we just have to find 90% of that volume and put it equal to the volume of the bowl. So remember, the volume of the cylinder is 1,923 centimeters cubed. And of course, the cylinder is the tin that we are talking about. So the volume of the tin will be the 1,923 centimeters cubed. So volume of tin is equal to the 1,923 cm cubed. And remember, the volume of the bowl is 90% of the volume of the tin. So volume of bowl is equal to 90% of 1,923. So that is 90 over 100 multiplied by 1,923 over 1. Now again, all this could be done on the calculator. Of course, 90 over 100 is 9 over 10. So we have 90, use the fraction button, over 100 multiplied by 1,923. Press equal. We get a mixed number. Just press the fraction button again to convert it to decimal. So that's 1,730.7 centimeters cubed. Now, if you didn't want to use the fraction button and you wanted to get the answers at decimal one time, okay, let's put 90 divided by 100. 90 divided by 100 and then multiply by 1,923. And see you get a decimal one time. 1,730.7. So we have 1,730.7 centimeters cubed. So now, if the volume of the bowl is 2/3 pi R cube, and the volume of the bowl is also 1,730.7, then 2/3 pi R cube has to be equal to 1,730.7. So I'll put, this would imply, spell a line here, separate these. All right, that 2/3 pi R cube is equal to 1,730.7. Now remember, in this question, we are using pi as 22 over 7. So let's put that in. So we have 2/3 multiplied by pi, which is 22 over 7, multiplied by R cube, and I'll put the R cube over 1. So I can simplify properly. Is equal to 1,730.7. So now we've seen that nothing would cancel with the fractions here. So we can multiply 2 by 22 and get 44, and the 3 by 7 and get 21. So it'll be 2 by 22, 44, 44 by R cube. So that'll be 44 R cube, and 3 by 7, 21 by 1, still 21. So we'll have 44 R cube over 21 is equal to, and I'll put this 1,730.7 over 1, so I could cross multiply one time. So 1,730.7 over 1. Now we're going to cross multiply. So 44 R cube by 1 is just 44 R cube. And 21 times this 1,730.7. So we'll have 21 times 1,730.7. Press equal. And we get 36,000 344.7. So we have 36,344.7. So now we have this 44 being multiplied by the R cube. So when we transfer the 44 across, the operation will change the division. Or you can say, you divide both sides of the equal sign by 44. All right, so you're going to get R cube is equal to 36,344.7 divided by 44. So R cube is going to be equal to, all right, 36,344.7 divided by 44. Press equal. So we get 826.0 so forth. So let's write this as 826 to three significant figures. So we have 826, and therefore R would just be the cube root of this 826. So R is equal to, so now what I could do, since I have the answer already on the calculator, I can just press cube root one time. So for me, I'll press second function and the x cube button, that's cube root, and press equal. So you see, find the cube root of the answer, and I got 9.38 and so on. So to three significant figures, we stop at the 8. After is a 2, so 9.38 centimeters. So we have 9.38 centimeters. And that will be a radius of the bowl. So now moving on to question 6 part B, we have in the diagram below, points L, M, and N are on the circumference of a semicircle. So this here is a semicircle. L, M, and N are on the circumference of the semicircle with center O. So this is the center. So L to O is the radius, O to N is the radius, and L to N is the diameter. And let's say now, and a radius of 18 centimeters. So I can put that in. All right, so from L to O is 18 centimeters, and from O to N is 18 centimeters. So the total diameter would be 36 centimeters. Now, what they want us to do is to calculate the total area of the shaded sections in the diagram. So in terms of the shaded sections, we have two components. We have this little piece here and this little piece here. Now, this is easy because here, let's start to find the area of the semicircle, which will be the entire thing, which is half the area of a circle. So the area of a circle is pi r squared. So let's find half of that. And here we have a triangle. Now, the important thing about this, by saying that the radius is 18 and O is the center of the circle, well, yes, from O to L is the radius and from O to N is the radius. So I have 18 here and 18 here. But remember, this is the circumference of the circle. And any distance from the center to the circumference is the radius. Therefore, from O to M is also the radius. So we also have 18 centimeters here. And we know the area of a triangle is base by height over 2, or a half base by height. And we know the base and the height of a triangle must always be at right angles to each other. And we see the right angle here. So therefore, this is the height of the triangle, being 18, and the base would be 36 centimeters. So it doesn't matter which one you work out first. So let's go to the semicircle first. So area of semicircle, and remember, it's a half times the area of a circle. So it's a half times pi r squared. So that's a half times, and remember the question says to use pi as 22 over 7. So 22 over 7 multiplied by the radius, and the radius is 18. So 18 squared. Now again, we can put all this into the calculator and work it out. So we're going to put equal to. So we're going to have a half. So 1 over 2 using the fraction button, multiplied by 22 over 7, so 22 over 7, multiplied by r squared, so that's 18, press the x squared button to square it, press equal, and we get 509 and 1/7. So I'm going to write 509 and 1/7 centimeters squared. Now as a decimal, all I have to do is press the fraction button, and it converts it into a decimal, which is 509.14, so on. Now, if you want to write the final answer as a decimal to 3 significant figures, what I should do is write these answers here to 4 significant figures, so I can approximate the final answer to 3 significant figures. So 1, 2, 3, 4. 1 is the 4th significant figure. After is a 4, so the 1 remain the same. So 509.1 to 4 significant figures. So I'll have 509 0.1 centimeters squared. So now for the area of the triangle, so area of triangle is equal to, and I'll just put base by height over 2, and the base being 18 plus 18, which is 36. I'll still write it like this, 18 plus 18, that's the base, times the height, which is 18, over 2. So all we get is 36 times 18 over 2. And I mean, you could do this on the calculator, but you know, you can cancel the 2 with the 36 and get 18. Canceling 2 with 36. So I'll get 1 here, and here I'll get 18. 2 to 36, 18. So what I'll end up with is just 18 times 18, which is 18 squared. So 18 times 18 is equal to 324. So we have 324 centimeters squared. So now the area of the shaded sections will be equal to the area of the semicircle, take away the area of the triangle. So that's 509.1, take away 324. And that's equal to 509.1, take away 324. And we get 185.1. Of course, I'll write this to 3 significant figures because remember that 509.1 was approximated. So let's write this as 185 to 3 significant figures. So 185 centimeters squared. Now, in this question 7, we have the diagram below shows the first 3 shapes in a sequence, which forms a pattern. Each shape is made using a set of small white counters and black counters. So we can see black counters here, and then we have the white counters here. And this will be shape 1. So we have 1, 2, 3, 4, 4 black counters, and 1, 2, 3, 4, 5, 6, 6 white counters. Now in shape 2, we can see that the black counters increased and also the white counters increased. Now we can see this 1, 2, 3, 4, this pattern here, right here, 1, 2, 3, 4. And then we have an extra row of black counters, and also we have 2 extra columns. As you can see here, we have 1, 2, 3 columns, and here we have 1, 2, 3, 4, 5 columns. So we have an extra column on the left-hand side and an extra column on the right-hand side. Now also notice the rows of white. We have 1, 2, 3 rows of white, and here we had 1, 2 rows of white. So what we are seeing is that we have a column on either side and an extra row of white. Also, we have the extra row of black counters as well. As you can see, 1, 2 rows of black counters, and then we have 1, 2, 3 rows of black counters. So now if you look at this pattern here, we have 1, 2, 3, 4 rows of black counters, and then we have 1, 2, 3, 4 rows of white counters. So the white went up from 3 rows to 4 rows, and the black counters went up from 3 rows to 4 rows. And remember also we have the added column on either side. So now if we want to complete the diagram below to represent shape 4, we need to add an extra row of white counters, and we need to put a column on either side here, and also have an extra row of black counters. So what I have here so far is, from here we have 1, 2, 3, 4 rows of black counters, and now I have 1, 2, 3, 4, 5 rows of black counters. And notice, we have this set up to give us the extra column on the left-hand side and the extra column on the right-hand side. So now we need to fill in this column with white counters, and remember we need to add an extra row of white counters. Similarly here, fill in this column with white counters as well. Alright, so far I have the extra column on the left-hand side and the extra column on the right-hand side. So now I just need to do the row with white counters down here. Okay, so I've added my extra row of white counters, but notice something. I have 1, 2, 3, 4 rows of white counters. And here I also have 1, 2, 3, 4 rows of white counters. So I know I'm supposed to have 5 rows because the rows of white counters going up by 1. So you see 2 rows of white counters, then we have 3 rows of white counters, then we have 4 rows of white counters. Therefore, here I'm supposed to have 5 rows of white counters. So I need to do an extra row of white counters. So now that we have our final row of white counters, this diagram would represent shape 4. We have 1, 2, 3, 4, 5 rows of black counters and 1, 2, 3, 4, 5 rows of white counters. Now moving on to part B, we have the number of white counters is W, the number of black counters would be B, and the total number of counters would be T. So that will be the total amount of black counters plus the total amount of white counters. That will be T. That form each shape follow a pattern. So the values for W, B, and T for the first 3 shapes are shown in the table below. Study the pattern of numbers in each row of the table and answer the questions that follow. So I want us to complete the rows marked 1, 2, and 3 in the table below. So here I have the table pretty small, but on the next page I'll have a bigger version of it. So let's go to the next page. Alright, so this is the table. We fill in all the information for part 1, part 2, and part 3. Remember, S is the shape number, W is the number of white counters, B is the number of black counters, and T is the total. So you can see that for shape 1, we have 6 white counters, 4 black counters, and the total will be 6 plus 4, which is 10. Let's go back to shape 1. We have 1, 2, 3, 4, 4 black counters. We can see for shape 1, we have 4 black counters. Then we have 1, 2, 3, 4, 5, 6 white counters in shape 1. And here we have for white counters for shape 1, 6 white counters. So in total, you'll have 6 plus 4, which is 10. So for part 1, we have for shape 4, we have 45 white counters. The number of black counters is missing, and the total number of counters is also missing. Now remember, we completed the diagram for shape 4. So if you want, you could go back to shape 4 and count the total number of black counters. Or you can recognize the pattern that's going on here. Because we have 1 plus 1 squared. Alright, so that's 2 squared, which is 4. Then we have 2 plus 1 squared, and 2 plus 1 is 3. And 3 squared is 9. Now notice, here is shape 1. Here is shape 2. And I'm seeing a 2 here. So 1, shape 1, then shape 2. And then look, shape 3. So if you follow the same pattern, we're going to have 4 plus 1, which is 5, and 5 squared is 25. But you can go back to shape 4, which is here, and count the number of black counters and see if you get 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So we have 25 black counters. So I'm just going to continue the formula here. So we have 4 plus 1 in brackets squared, which will be 5, and 5 squared is 25. And of course, the total number of counters will be 45 white plus the 25 black. So 45 plus 25 is equal to 70. So we have 70 as the total number of counters for shape 4. So we will have 70 here. So now for part 2, we have to fill out the shape number, the total number of white counters, but they are telling us that the total number of black counters is 144. And the total amount of counters, both black and white, would be 420. Now, if you think about it, the total amount of white counters plus the total amount of black counters supposed to give you this 420. So therefore, if you take away the 144 from 420, I'll get the total amount of white counters that's supposed to go here. So I'm just going to put 420 take away 144, which is equal to. So if we put 420 take away 144, we get 276. So here I'm going to write 276. So now we just need to figure out what is the shape number. Now this part here gives it away because look at all these numbers. These numbers are square numbers. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and we know 12 squared is 144. So I'm just going to write here, we know 12 squared is 144. And if we look at the pattern as to how we arrive at that, we see the shape number plus 1 in brackets squared. Same thing here, shape number is 2 plus 1 in brackets squared. Shape number is 3 plus 1 in brackets squared, and so on. So if you had to get 12, the shape number has to be 11 plus 1 to get 12. So therefore, it will be 11 plus 1 in brackets squared, which is equal to 144. And that tells me the shape number is 11. Therefore, we're going to put 11 here. So now down here for part 3, we have the nth term, which is the nth shape number. So we have the number of white counters missing here, the number of black counters missing here, and we have the formula for the total number of counters when the shape number is n. So this will be the formula for the total amount of black counters when the shape number is n. Same thing here, the formula for the total number of white counters when the shape number is n. Now, if you follow this pattern here, let's look at it. We have shape number is 1, we have 1 plus 1 in brackets, and then we have 2 times 1 plus 1. Then we have shape number 2, we have 2 plus 1, so I've seen something here, from 1 to 2. Then here we have what? Same 2, but we go from 1 to 2, and then here's the same 1. So I'm seeing where the shape number is changing the formula. All right, it's changing it here and here. Now notice here for shape number 3, I have 3. So see 1, 2, 3, 1, 2, 3, and 1, 2, 3. Everything has remained the same. Therefore, for the nth term, what's going on the outside here will have to be n, and in brackets here will have to be n. So what I'll have is n plus 1. Because we've seen that here, we have 3 plus 1, 2 plus 1, 1 plus 1. So n plus 1. Then we have 2 times the shape number plus 1. And remember the shape number is n. So we have 2 times n plus 1. And this will be a formula for the total number of white counters. Now for the total number of black counters, that's easy because we already established that pattern here. The shape number is 1, then shape number is 2, then shape number is 3, then 4, and so on. So when the shape number is n, we'll just have n plus 1 in brackets squared. So here we just have n plus 1. Of course, we already have brackets here, squared. And this will be all the information we need to fill out on this table. So now moving on to part C, we have the expression for the total number of counters T is equal to W plus B. And that was obvious because we know the total number of white counters plus the total amount of black counters gave us the total number of counters. So we have the expression for the total number of counters. We have the expression here in shape S is given by T is equal to AS squared plus BS plus 2. Now remember to say shape S. When we had the shape, we had shape 1, shape 2, shape 3, shape 4, so on. Therefore, S will be the shape number. So when we see S in the formula here, that will be the shape number. So we have where A and B are both positive integers. So by substituting suitable values for S, so remember S is the shape number, right? Show that the total number of counters in shape 1, so for shape 1, S is 1. And shape 3, so for shape 3, S is 3. In terms of A and B is represented by the equations A plus B is equal to 8 and 3A plus B is equal to 14 respectively. So when I say respectively, that means this is for shape 1 and this is for shape 3. So first, let's start with shape 1. So I'm going to put for shape 1. We'll have S is equal to 1. Now remember, this is the formula here, right? T is equal to AS squared plus BS plus 2. So the S is equal to 1 for shape 1. Also T, the total number of counters. If you go back to the table, for shape 1, the total number of counters T is equal to 10. So I'm going to use that. All right, so S is equal to 1 and T is equal to 10. So now let's write down this formula here. So we have T is equal to AS squared plus BS plus 2. Now remember, T is equal to 10 and S is equal to 1. So I'm going to put 10 is equal to A. We don't know what A is. S is 1, so that's 1 squared, because S squared, plus B times S, and S is 1, plus 2. Let's work that out. 1 squared is just 1, so that's just A times 1. B by 1 is just B, plus 2. Let's put the 10 here as well. Now what we could do is transfer this positive 2 across the equal sign, because in terms of like terms, A times 1 is just A, and this is B. So A and B, you can't add them, but the 10 and the 2 are your constants, and those are like terms, therefore we can add or subtract. So I'm going to transfer 2 across. But before I do that, I'll just multiply a by 1 and get a. So we have 10 is equal to a plus b plus 2. All right, so as I said, I'm going to transfer positive 2 across the equal sign. I will turn to negative 2. So we have 10 take away 2 is equal to a plus b. And 10 take away 2 is 8 is equal to a plus b. And, just look back to front, but a plus b is equal to 8. Same thing I have here, a plus b is equal to 8. So if you want, you can just put the a plus b first, and then put it equal to 8. So we have shown this part for shape 1. Now we need to show this for shape 3. So I'm going to put for shape 3. We're going to have S is equal to 3, and the total number of counters, we just go back to the table. And for shape 3, right, see shape number 3, total number of counters is 44. So that means T is equal to 44 for shape 3. Let's come back here now. So T is equal to 44. So now I'll write back this formula here. T is equal to AS squared plus BS plus 2. So we have T is equal to AS squared plus BS plus 2. So remember, T here for shape 3 is 44. So let's put that in. 44 is equal to A times S squared. And remember, S here is 3. So that's 3 squared. Plus B times S. So S is 3 plus 2. So now we have 44 is equal to A times 3 squared is 9. All right, so this is a A and this is a 9, right? So plus B times 3 is 3B plus 2. Now A times 9 is just 9A. So I'll have 44 is equal to 9A plus 3B plus 2. And again, in 9A, this term, remember terms are separated by plus or minus signs, right? So 9A is a term, 3B is a next term, and this 2 is a next term. So in terms of like terms, this is a term in A, this is a term in B, we cannot add. But this 44 is a constant, and this 2 here is a constant. And therefore, the 44 and the 2 are like terms, so I need to bring them together. So I transfer the positive 2 across the equal sign, I'll turn negative 2. So I'll have 44 take away 2 is equal to 9A plus 3B. And 44 take away 2 is 42. Is equal to 9A plus 3B. Now, what we have here is 3A plus B is equal to 14. What I have here is 9A plus 3B is equal to 42. Now I'm noticing something here. I'm seeing 3 and 9. Therefore, 3B is divisible by 3 and 9A is also divisible by 3. So now what I'll do is check to see if 42 is divisible by 3. So I'm just going to put 42 divided by 3 and we get 14. And that's what we want. So I know when I divide 42 by 3, I would get 14. So what I need to do is divide both sides of the equal sign by 3 and I'll get this. So I'm going to put the 42 divided by 3 is equal to 9A plus 3B divided by 3. So this will give 14. This will give 9A over 3 plus 3B over 3. So we have 14 is equal to, the 3 and the 9 cancels and give you 3. So you have 3A. And the 3 and the 3 cancel, so that's remain with B. So that's plus B. And now we have 3A plus B is equal to 14, which is exactly this. 3A plus B is equal to 14. So you can just write it that same way with the 3A plus the B first, and then equal to 14. And there you have it. You have shown A plus B is equal to 8 for shape 1, and 3A plus B is equal to 14 for shape 3. Now notice the question never asked you to find the values of A and B, but if they did, what you have here is a pair of simultaneous equations, which you could solve simultaneously and get the values of A and B. But the question didn't ask for that, so this is all we need to do. So now in question 8, part A, we have the diagram below shows the graphs of two functions on the same pair of axes. The lines G and H are perpendicular. So this is the line G here. This is the line H. We can see 90 degrees between the two lines. So they are at 90 degrees to each other, meaning they are perpendicular. Now the first question we have is to determine the equation that represents the line G. So this is the line G, and we want the equation of the straight line, which is in the form y is equal to mx plus c. So in order to find the equation of the straight line G, we would need the gradient and the y-intercept. Now I can see that we have the y-intercept as 3. That's where the line touches the y-axis. So all I would need to do is work out the gradient of the line G, because I already have the y-intercept. So I can write down that c is equal to 3. And what I could do is form a triangle here, where I can get my change in y and change in x. Now we can see as we move from left to right, this line is going upwards. Therefore, it has a positive gradient. Therefore, my change in y would be positive. And we are going from the origin, which is 0 here, all the way up to 3. So my change in y is just 3. And now my change in x, which is the horizontal distance, is from 0 to negative 6. So the change in x would just be 6. So now my gradient, and the symbol for the gradient is m, would be the change in y over the change in x. And my change in y is 3. And my change in x is 6. Therefore, my gradient is equal to a half. So now I can write the equation of the line in the form y is equal to mx plus c. And I know the y-intercept is 3, because that's where the line touches the y-axis at 3. And I know my gradient is a half. So all I have to do is put in those values. So for m, I'm replacing that with a half. And for c, I'm replacing that with 3. And this is the equation of the line G. So now moving on to part 2, we want to determine the equation that represents the line H. Now remember, the line H is perpendicular to the line G. And therefore, if we know the gradient of the line G, then the gradient of the line H would just be the negative reciprocal of the gradient of the line G. So I will call the gradient of the line G m1, and we work that out to be a half. Therefore, the gradient of the line H, I'll call that m2, has to be, well, the reciprocal of a half is 2 over 1, which is just 2, and then you change the sign, so that'll be negative 2. So if you multiply m1 times m2, you would get a half times negative 2, which is just equal to negative 1. So if two lines are perpendicular, when you multiply their gradients, you would get negative 1. So we see that the gradient of the line G is a half. Therefore, the gradient of the line H has to be negative 2. So that when we multiply two gradients, we will get negative 1. And that's because they are perpendicular. So now that we have the gradient of the line H, we just need the y-intercept for the line H. Now we are not seeing where this line touching the y-axis, so we'll have to work it out. So in order to work out the y-intercept for the line H, we would need the gradient and any point that the line passing through. Now we can see that this line H is passing through 4 on the x-axis, and the coordinates of this x-intercept will be 4 on the x and 0 on the y. So I'm going to put using m is equal to negative 2 and the point the line passing through, which is 4 on the x and 0 on the y, which is the x-intercept of the graph. Now remember, this could be any point that the line passing through. So now this is my x part of the coordinate and this is my y part of the coordinate. The equation of a straight line is in the form y is equal to mx plus c. And therefore, I can replace this y with the y part of the coordinate, the x with the x part of the coordinate, that that the line passing through, and then the m is the gradient, replacing that with the negative 2. So the only unknown will be c, which means we can solve for c. So for y, I'm putting 0. For m, I'm putting the negative 2. And that's been multiplied by x, and x is 4. And of course, c is my unknown. Now 0 is nothing, right? So 0 Negative 2 by 4 is negative 8 plus c. We transfer the negative 8 across, it will turn positive 8. So therefore, c is equal to positive 8. So if we write the equation of the line in the form y is equal to mx plus c, and we put in the values for m and c, we would have y is equal to m, which is negative 2, times x, plus c, which is positive 8. And this would be the equation of the line h. So now for part 3, we want to determine the coordinates of the point P, and we want to show all working. So we've seen that P is the point where the two lines intersect. Now I wrote down the equation of the line G, which is the y is equal to half x plus 3, which we found in the first question. And then we have the equation of the line H, which we just found as y is equal to negative 2x plus 8. So in order to find the coordinates of the point of intersection of these two lines, we'll have to solve these two equations simultaneously. So I'll write my first equation, which is y is equal to half x plus 3. And my second equation, which is y, is equal to negative 2x plus 8. This is my equation 1, and this is my equation 2. Now we have an interesting situation here. The value for y in both equations would be the same, as well as the value for x in both equations will be the same, because that's the point at which the two lines intersect. So if y is equal to half x plus 3, and y is equal to negative 2x plus 8, it would simply imply that a half x plus 3 is equal to negative 2x plus 8. And therefore, you could bring all like terms together. So the half x together with the negative 2x. So we have a half x. I'll transfer the negative 2x across the equal sign. I will turn positive 2x. I would leave the positive 8 on the right-hand side. And I'll transfer the positive 3 across the equal sign. I'll turn to negative 3. So now a half x plus 2x is just 2.5x. And 8 take away 3 is just 5. So now we have 2.5x is equal to 5. So we have this 2.5 here is being multiplied by x. And remember, we want to solve for this x. So if we transfer 2.5 across the equal sign, the operation will change from multiplication to division. So we'll get x is equal to 5 divided by 2.5. Now we could go and type this into the calculator and work it out one time. Or we could convert this to improper fraction. 2 by 2 is 4 plus 1 is 5. So we'll have 5 divided by 5 over 2. We'll change this divide to multiply. So we have 5 multiplied by, and invert my divisor. So invert this. So the 2 comes on top and the 5 comes below. And now this is something we could work out. I could simply put this 5 over 1 and we could cancel up. So I'll do that. So I'm writing the 5 over 1 like that. So that's equal to x. And this 5 will cancel this 5. 5 into 5, 1, 5 into 5, 1. And all we remain with is 1 by 2 over 1 by 1. So the answer is just 2. So we're going to have x is equal to 2. Now, a coordinate has an x component and a y component. All we found so far is just the x component. Now we can substitute this value for x into any of the two equations. So now equation 1 reads y is equal to a half times x. So think about it as a half times 2. That's just 1. So you're going to put 1 plus 3, which is 4. So y is 4. Or you can use equation 2, where we have y is equal to negative 2 times x. And remember, x is 2. So that's negative 2 times 2, which is negative 4. And negative 4 plus 8 is 4. So it doesn't matter which equation you use. You're going to get y is 4 when x is equal to 2. So I'll just substitute x is equal to 2 into, and let's use equation 1. Equation 1. So we have y is equal to a half x plus 3. So y is equal to a half times x, and x is 2. And we know a half of 2 is 1. So y is equal to 4. So that means the coordinates of P will just be 2 on the x and 4 on the y. And that would be your answer. All right, so moving on to part B, part 1, we have to write this quadratic in the form a x plus h in brackets squared, so that's our perfect square there, plus k. So this is just completing the square. So I'll write the 4x squared, take away 24x plus 31. So now the first step would be to get rid of this 4 in front of this x squared. So in order to do that, I have to factor out the 4, which means to divide everything by 4. So I'm going to write 4, put some brackets like that, divide 4x squared by 4 and get x squared. 24x divided by 4 is just 6x. And then we're going to have 31 divided by 4. So let's write that as 31 over 4. Because, if you divide this, you're going to get a remainder. So I'll close my brackets. Then I'm going to set things up for my perfect square. So brackets like that. I'm going to bring back down this x. The sign here is negative. I'm going to find half of this 6, which is 3. I'm going to write back the 31 over 4. And I'm always going to take away this number here squared. So that'll be 3 squared. Let's put back the brackets now with the 4 on the outside. So what I have to do now is to work out this 31 over 4, take away 3 squared. So I'm going to write 4, put back everything. All right, and I'll do this part on the calculator. So I'm going to have 31, use the fraction button, over 4, take away 3 squared. And I'm going to get negative 1 1/4. Prefer to write this as an improper fraction. So I'll press second function, fraction button, so I get negative 5 over 4. So I'm going to write here negative 5 over 4 and close the brackets. So now to get rid of this big brackets here, remember at the beginning, I divided everything by 4 to pull this 4 out. So now I'll multiply everything by 4 to get rid of this big brackets, right? Which is this expansion. So when I multiply this 4 by the x take away 3 in brackets squared, I cannot say 4 by x and 4 by 3, right? Because of this square sign here. I'll have to, work out the perfect square first and then expand. But, we don't want to do that. So we're going to leave it as 4 times x take away 3 in brackets squared. And then we'll multiply the 4 by the negative 5 over 4. And if you look at what's going to happen here, 5 over 4 multiplied by 4, which is 4 over 1. And the 4s will cancel out each other and you remain with 5. So, of course, it's negative, so you're going to get negative 5. And now I've written this quadratic in this form where a is 4, h is negative 3, and k is negative 5. Now moving on to part 2, we have on the axis below, sketch the graph of 4x squared take away 24x plus 31, indicating the coordinates of the maximum/minimum point and the y-intercept. So since we are going to sketch the graph, I'll write out the quadratic as y is equal to 4x squared take away 24x plus 31. Now the y-intercept will be 31 because you obtain the y-intercept when x is equal to 0. So if I were to substitute x is equal to 0 into this equation, if I put x is 0 here, any number by 0 is 0. So this will take this will be 0. If I put 0 for x here, this will be 0. And the only thing that remains is y is equal to 31. So that's my y-intercept, 31. So now I'm going to recall my answer from part 1, which is here. So I wrote this quadratic in this form. So I'm going to write that back. 4 times x take away 3 in brackets squared take away 5. So we're going to have 4 times x take away 3 in brackets squared take away 5. And the important thing about this form is that the turning point, you just have to change the sign on this number here. All right. And then this negative 5 outside here will be the y component of your turning point. So this here will be x component. Change the sign on it so you get positive 3. And this number outside here will be a y component of your turning point. So now to address the maximum or minimum point, well, seeing that the number in front of x squared, which we call the coefficient of x squared, is positive, the graph is a minimum. Okay, so my turning point, as I said, change the sign in front of this number. So from negative 3, it will be positive 3. And this will just be the y component. Negative 5 is a minimum. Let's put min. All right, so we have the turning point. I already explained to you that this number here is your y-intercept. And y-intercept is 31. So now looking at the axes that they gave us to sketch this graph, they didn't put any number in. So we'll have to number this. We need to cater for 31 on the y-axis, somewhere up here. Positive 3 on the x-axis, somewhere here. And then we have to go down to negative 5, somewhere down here. So I'm just going to use my ruler to put some markings on the line. And now we'll just put some markings for the y-axis. Alright, so I'm done with my ruler. As you can see, what I did was use 1 centimeter spacing. Okay? So for the y-axis, seeing that only have 4 centimeters here, I'll just let every 1 centimeter be 5. So here will be negative 5. Here will be origin 0. Here will be positive 5, positive 10. Remember, I need 31, right? So 15, 20, 25, 30. And here will be 35. So that covers 31 for the y-intercept. And for the x-axis, I'll just count here as 1, 2, 3. That's all I need. Okay, so remember, this is a minimum curve. My turning point would be 3, negative 5. So if I draw a line from 3, come down like this, intersecting with a line from negative 5, that would be my turning point. And my y-intercept will be positive 31, which is about here. And remember, as I estimate, is just a sketch. So now what I need to do is make a parabola where here has the minimum point, goes up, touches this point. Of course, try and make it symmetric about this point. All right, so let's see. All right, so that's half of it there. And the other half here. Not perfect, freehand. All right, so this would be your sketch of the graph showing the turning point and the y-intercept. All right, so now I'll just indicate the coordinates at the turning point. So I'll just put x here for it. And I'll put the coordinates 3, negative 5. And remember, that was a minimum. All right, so minimum point. And then the coordinates are the y-intercept. So that would be 31 on the y, but 0 on the x. So that would be 0, 31. All right, so now the last part of the question, which is part 3, is to state the equation of the axis of symmetry. Now, this graph is supposed to be symmetric about this turning point. Therefore, the axis of symmetry will be this vertical line passing through the turning point. And that vertical line will pass through 3 on the x-axis. So the equation of the axis of symmetry would just be x is equal to 3. So for part 3, equation of the axis of symmetry is x is equal to 3. Now in this question 9 part A, we have K, L, M, and N are points on the circumference of a circle with center O. So we see in the circle here, we see in the center O, and we see in the K, L, M, and N. Obviously, this quadrilateral, which is a 4-sided shape, all the vertices touch the circumference of the circle, which would make K, L, M, N a cyclic quadrilateral. Then we have XY is a tangent to the circle at K. So we have the XY being a tangent to the circle at K, meaning this tangent touches the circle at K. And we know from O to K is the radius, and the angle between the tangent and the radius is a 90-degree angle. Then we have angle LKY is equal to 48 degrees, which is shown here. Then we have angle MKO is 12 degrees, which is shown here. And then we have angle XKN, which is 56 degrees, which is shown here. Now question A part 1, we want to find the value of angle KOL, giving reasons for each step of your work. So let's highlight angle KOL. Okay, so we have K to O and then O to L. So this is the angle that we want to find. Now we've seen that this angle is at the center of the circle. And if you remember the rule for the angle at the center of the circle, we know the angle at the center of the circle is twice the angle at the circumference. Now if we look at the chord or the arc that this angle is standing on, the chord would be KL and the arc also is K to L. And therefore if you look at the angle at the circumference that stands on the same chord, that will be this angle here. So this angle stands on the same chord KL as this angle. This one is at the center and this one is at the circumference. So this one at the center will be twice this angle here at the circumference. Now the thing is, we don't know what this angle is. Now there's another rule that says the angle between a tangent and a chord is equal to the angle in the alternate segment. Now we've seen that we have this tangent here from X to Y, and we have this chord KL, and the angle between the tangent and the chord is 48 degrees here. So now we are looking for the angle in the alternate segment. Now that angle in the alternate segment must be touching the circumference of the circle. So below KL is your minor segment, and above KL is the major segment. So the 48 degrees is sort of in the minor segment. So the angle in the alternate segment has to be the one in the major segment. And as I said, the vertex of that angle must touch the circumference of the circle. So again, you are looking for an angle that's standing on the chord KL that's touching the circumference of the circle. And that angle is right here. Therefore, if here is 48 degrees, then here is also 48 degrees. All right, so let's write our reason for this angle being 48 degrees, which is, angle between tangent and chord is equal to the angle in the alternate segment. So I'll write angle KML. So angle KML is equal to angle YKL, which is equal to 48 degrees. And my reason, angle between tangent and chord is equal to the angle in the alternate segment. All right, so that's my reason for this being 48 degrees. And now that we know here is 48 degrees, we know this angle here must be twice that angle. So angle KOL will be 2 times 48, which will be 96. So angle KOL, which is equal to 48 degrees times 2, which is equal to 96 degrees. And your reason for that would be angle at center is equal to 2 times angle at circumference. All right, so that will be our answer for angle KOL, and we gave reasons for each step of our working. So I'm just going to write here is 96 degrees. All right, so next for part A, part 2, and then part A of that part 2, we have to find the value of each of the following angles, and that first one is angle LMN. So we are going from L to M to N. So that's L to M, and then M to N. And this is the angle that we want to find. Now, what I'm noticing about this angle is that, I'm seeing a cyclic quadrilateral. So I'm going to highlight that. So I'm going to highlight here and highlight here. Now, the thing about a cyclic quadrilateral is that the opposite angles are supplementary, and supplementary means add up to 180. So if I highlight this entire angle here, this whole angle, right, just forget about the 12, this whole angle from angle NKL, this whole thing, plus this angle here, angle NML or LMN, all right, must add up to 180 degrees. Now, the thing is, how do we get this whole angle? All we know is this 12 here. Now, here we have a straight line, and we have here as 56 and here as 48. Now, we know the angles along a straight line must be equal to 180 degrees. So the 56 plus 48 plus this whole angle here must be equal to 180 degrees. So all we have to do is add up the 56 and 48 and take it away from 180, and we'll get this angle here. And this angle will be NKL. So angle NKL is equal to 180 degrees, take away 56 degrees plus 48 degrees. And that's equal to 180, take away open brackets, 56 plus 48, close brackets, and we get 76. All right, so this is 76 degrees. Therefore, this whole angle is 76 degrees. And as I said, the opposite angles of a cyclic quadrilateral are supplementary, meaning they must add up to 180 degrees. So angle LMN, all right, angle LMN will be equal to 180 degrees, take away 76. All right, so 180 take away 76 is equal to 104. So angle LMN is equal to 104 degrees. Now notice, for this question, they never told us to write a reason for our answers. But because this is a teaching moment, I'll write the reasons. So for this one, the reason would be straight angle. And for this one, I'll write the opposite, OPP for opposite, angles of a cyclic. I'll put QUAD full stop, which is short for quadrilateral. So opposite angles of a cyclic quadrilateral are supplementary. I'll put SUPP full stop for supplementary. All right, so this is your answer for angle LMN. It's 104 degrees. Now for part B of part 2, where we have to find the value of each of the following angles, we have angle KLO. So that'll be K to L to O. So that's K to L and then L to O. So this is the angle that we want to find. Now, I'm looking at this. And remember, up here was 96 degrees. Let's put that in. Here was 96 degrees. Now, O to L is the radius, and O to K is also the radius. So, OK and OL are equal to each other. Therefore, this triangle here would be an isosceles triangle. Let's just connect and form the triangle. And I'll put a dash on this side like that, a dash like that, to show that these two sides are equal to each other. And if I had to write a reason for that, I would put that, OK is equal to OL, and the reason for that would be radii, all right, the plural of radius. So now, what do we know about an isosceles triangle? Well, we know that the base angles of an isosceles triangle are equal. So this angle is equal to this angle here. So that'll be this angle here. And we know the sum of the interior angles of a triangle must add up to 180 degrees. So what I could write is that angle OKL is equal to angle OLK, because the base angles of an isosceles triangle are equal. So angle OKL is equal, the angle sign here, to angle OLK. And my reason, base angles of an isosceles triangle are equal. So now we could say, 180 take away 96 and then divide the answer by 2, and we get these two angles here. So angle KLO is equal to 180 take away 96 divided by 2. So I have open brackets, 180 take away 96, close the brackets, and then divide by 2. And we get 42 degrees. So I'm going to write 42 degrees. So here's 42. And here's also 42. All right, and that will be my answer for angle KLO. What I get right here for a reason, since I already have the base angles of an isosceles triangle are equal, is that the sum of the interior angles of a triangle is equal to 180 degrees. All right, so sum of interior, INT full stop for interior, angles of a triangle is equal to 180 degrees. And that'll be my reason. So now for part C, we want to find the value of angle MLK. So that's MLK. Let's highlight that. All right, so angle M to L and L to K. All right, so that's this angle here. All right, so what I'm seeing is I can use this triangle here because, I know some information about this triangle. For one, we found up here to be 48 degrees. If you remember that, the angle between the tangent and the chord was equal to the angle in the alternate segment. We found this entire angle to be 42 degrees. So this whole angle was 42 degrees. But here we have 12, so 42 take away 12 will give us this part of the angle here. So I'll highlight the triangle. Okay, so this is the triangle that we're looking at. We know the sum of the interior angles of this triangle will be 180 degrees. And as I said, if here is 12 and this whole angle was 42, then 12 take away 42 is 30. Therefore, this angle here is 30 degrees. All right, so I'll just write that out, that angle MKL. All right, so angle MKL was simply equal to 42 take away the 12, which gave us 30 degrees. We don't have to write any reason for that because, we already found this angle. We already said that, this was one of the base angles of the isosceles triangle. Across here was 42, so here was 42. All right, so 12 take away 42 give us 30. So now we can say that the sum of the interior angles of this triangle is equal to 180 degrees. So we had to add the 48 and the 30 and take it away from 180 and we'll get this angle here. So angle MLK is equal to 180 degrees, take away 48 degrees, plus that 30 degrees. So that will be equal to, all right, we have 180, take away, open brackets, 48 plus 30, close the brackets, and we get 102 degrees. So we have 102 degrees. So here's 102 degrees. Of course, the reason for this is the sum of the interior angles of a triangle is equal to 180 degrees. Okay, and that's your answer for MLK. So now moving on to part D, where we're going to find the value of angle KNM. So let's highlight that. Angle K to N and then N to M. All right, so this will be the angle that we want. And what I'm seeing here is that, we had the cyclic quadrilateral, and these two angles will be the opposite angles of a cyclic quadrilateral. So let's highlight that. So there's my cyclic quadrilateral highlighted. And this is the opposite angle that I'm talking about. And if you recall, we found this entire angle to be 102 degrees. So we're going to put here as 102 degrees, which we found already. So again, these two are the opposite angles of a cyclic quadrilateral. Therefore, when you add them up, well, they are supplementary. So when you add them up, they must add up to 180 degrees. So angle KNM is simply equal to 180 degrees, take away that 102 degrees. And that will be equal to 180 degrees, take away 102, and we get 78 degrees. And our reason would be that the opposites, OPP for opposites, angles of a cyclic quadrilateral are supplementary. All right, and that's your answer here, 78 degrees for angle KNM. So moving on to part B, we have E, F, G, and H are 4 points on level ground. So we are seeing that E, F, G, and H, will be on level ground, being horizontal. We have the diagram below gives the information on the distances and angles between the points. Now we can see that here, 54 degrees, X, we have the distance 5.3 from H to G, G to F is 6.9 meters, and then H to F is 11 meters. Now, this first question here, they want us to show that the value of x is 29.5 degrees correct to 1 decimal place. So we want to find the value of x. So what I would do, looking at this situation here, all right, this is a trig question, which means we are dealing with a triangle, right? And the angle x is within this triangle here. So what I could do is draw this triangle separately. Okay, it doesn't have to be perfect. So here'll be 5.3 meters. Here'll be a 6.9 meters. And here'll be 11 meters. And here'll be an angle x. Here'll be h. Here'll be g. And here'll be f. Now, when it comes to our sine and cosine rule, these capital letters represent the magnitude of the angles, and the common letters represent the length of side. So opposite angle G will be common G, which will be 11 meters. So I'm going to write common G here. Opposite angle F will be common F, which is 5.3 meters. So this is common F here. And of course, opposite angle H, which is X, would be common H, which would be 6.9 meters. So that's common H. Now, we have all three sides. We don't have any angles. So the sine rule is out. So what we could do is use the cosine rule because we have all three sides to find this angle x. Now, we know the cosine rule. If you want the angle x, which is h, we must start with side h and end with angle h. So the formula is going to look like this. Common h squared is equal to the other two sides would be f and g. So f squared plus g squared. Take away fg, cosine angle h. And remember, angle h is this angle x that we want to find. So now let's put in the values. All right, so common h is 6.9. So we're going to have 6.9 squared is equal to, then we have common f. So common f is 5.3. So we're going to have 5.3 squared plus, then we have common g. Common g is 11 meters. So we're going to have 11 squared. Take away 2 times fg. So we're going to have 5.3 here times g, and g is 11. Then we're going to have cosine angle h. And instead of writing angle h, I'll just put the x. All right, so x. Now, what I like to do is to work all this out on the calculator. So I'll work out the 6.9 squared, write the answer here. Then I'll work out all this here. But remember, on the calculator, this goes together. Let's put some brackets. All right, so brackets here. So you're going to work out this, get the answer. And then we're going to work out this here, get the answer and write it down. Now, we can't get a full whole number for this because we are the cosine x. All right. So I'm going to put my equal sign. So I'm working out the 6.9 squared. So 6.9, we squared that. We get 47.61. All right. So we have 47.61. Then we have 5.3 squared plus 11 squared. And we get 149.09. So we have 149.09. Take away. And then we're going to work out the 2 times 5.3 times 11. Okay, and we get 116.6. So that's going to be 116.6 and then the cosine x. So now these two terms are not like terms, so you can't subtract these two numbers because this 116.6 has been multiplied by the cosine x. So what you have to do is transfer this across here. Or, since this is negative, I could transfer this 116.6 cosine x across the equal sign, so it turn positive, and then this 47.61 across here, I will turn negative. All right, so this line here is the same thing that I have up here. I'm just going to do the transferring to show you. All right, so when I take this negative 116.6 cosine x and transfer it across the equal sign, this negative sign will change to a positive sign. So I'm just going to bring that here. And I'm going to take this 47.61, and this is positive 47.61. And when I transfer it across the equal sign, it's going to change to negative 47.61. And I'm going to bring it right here like that. I'm going to bring this here. And now, seeing that there's nothing in front of this 116.6, I can remove the positive sign. So now I can simply subtract these two numbers. So I have 149.09, take away 47.61, and that's equal to 101.48. So we have 116.6 cosine x is equal to 101.48. And now I'll transfer this 116.6 across the equal sign, and the operation will change from, 116.6 multiplied by cosine x to, the 101.48 divided by 116.6. Or I could say, divide both sides of the equal sign by 116.6. So either way, you're going to get cosine x is equal to 101.48 divided by 116.6. So x would be equal to the cos inverse of the 101.48 divided by 116.6. So x is equal to the cos inverse of 101.48 divided by 116.6. And that's equal to, all right, so I'm going to press second function, then cos. See cos inverse come up, open my brackets, and put 101.48 divided by 116.6. Close the brackets, press equal. And you see I get 29.50 and so on. So to one decimal place, this is just 29.5. So I'm going to get 29.5 degrees. And you see, we have shown that the value of angle x is 29.5 degrees, correct to one decimal place. So moving on to part 2, we have a vertical tower GT is constructed at the point G. So at G, we're going to construct a vertical tower and is pivoted to the ground at the points E, F, and H. All right, so this is sort of like a 3D kind of shape we're looking at here. I know this two-dimensional surface can't really represent that, but E, H, and F is horizontal, and we're going to have a tower coming up at G. So if you read the question carefully, you see a vertical tower GT. So G going to be the ground, and T will be the top of the tower. So you're not seeing T here, right? So that's in G. So the tower is constructed at G, and will rise up vertically to the point T. Is constructed at the point G and pivoted to the ground at the points E, F, and H using pieces of wire. So from H to the top of the tower T, you're going to have a wire connecting. I know you're not seeing the T, all right, but T is the top of the tower. F to the top of the tower T, you're going to have a wire connecting it. And E to the top of the tower T, you're going to have a wire connecting to stabilize the tower. Now we're saying that the angle of elevation of the top of the tower T, see, the top of the tower is T. Therefore, G is at the bottom of the tower. From the point F is 31 degrees. So we deal with F. This 6.9 meters will be a horizontal distance, okay, from F to G. So let's draw that out. So what we're going to have here is a vertical tower, all right, where, here's the top of the tower T, and the bottom of the tower is G. Then horizontally to the point F, all right, this is F. We're going to have that 6.9 meters. And therefore, the wire connecting F to the top of the tower is going to be this line here. And we're saying the angle of elevation, so from horizontal looking up from F, would be this angle here. So now the angle of elevation of the top of the tower T, so the top of the tower T, from the point F, from F, is 31 degrees. So you know the angle of elevation must be taken from a horizontal line. So horizontal line, and then from F, go up, is 31 degrees. Therefore, here is 31 degrees. here'll be a right angle. Because, vertical tower, horizontal ground, 90 degrees. And the length of the wire used will be the length of the hypotenuse of this triangle, TF. So if you label the triangle, opposite the right angle is the hypotenuse. Opposite the angle that's given will be the opposite side. And the remaining side will be the adjacent side. So we want to find the hypotenuse. That's our unknown. We have our angle. We cannot use opposite because that's also an unknown. We could only have one unknown, and that one unknown is going to be hypotenuse. Therefore, we can't use opposite because, to solve an equation with two unknowns, that'll be impossible unless it's simultaneous equations. So therefore, we have to use adjacent because we know the length of the adjacent side. So you'll ask yourself, which trig ratio has adjacent and hypotenuse? So you say so car toi, and that'll be ka. Adjacent and hypotenuse is cosine. All right, so we're going to have cosine theta is equal to adjacent over hypotenuse. So cosine 31 degrees, the adjacent is the 6.9, and the hypotenuse is TF. All right, so we want to cross multiply here. So you're going to put the cosine 31 degrees over 1 is equal to 6.9 over TF. So multiplying cosine 31 by TF, we're going to get TF cosine 31 degrees, and 1 by 6.9 will just give us back 6.9. So now TF is being multiplied by cosine 31. So when we transfer the cosine 31 across equal sign, it'll turn to division. It'll go under the 6.9. But you can say, divide both sides of equal sign by cosine 31. So what we're going to get is TF is equal to 6.9 divided by cosine 31 degrees. So TF is equal to, all right, we have 6.9 divided by cosine of 31. Make sure my calculator in degrees. Press equal, and we have 8.049. Now in the exam, you always want to approximate these answers to 3 significant figures. If it's an angle, you use 1 decimal place. So 1, 2, 3, stop at the 4. After the 4 is a 9, so we have 8.05. All right, so 8.05, and that'll be meters. So the length of wire that was used to secure the point T to the point F, that's the length of wire here, is equal to 8.05 meters. So next, for part 3, we have the bearing of E from H is 228 degrees. Find the bearing of H from E. So that's the bearing of H from E. Now, we already have the note line on E. And we know bearings are taken in a clockwise direction from the note line. Therefore, we want to find this angle right here. So you see, from the note line going in this direction is clockwise. And this is the bearing of H from E. Remember, we have here that the bearing of E from H is 228 degrees. So E from H. E from H. So we have the note line on H, and we're taking the angle in a clockwise direction from this note line, and that angle has to be 228 degrees. So in a clockwise direction, we're going all the way around to touch here like that. And that whole angle has to be 228 degrees. Now let's just draw a separate diagram with this information. All right, so I have the line connecting E to H. I have the note line on E, the note line on H. Now, what I could do, since I want this angle here, is I could bring a straight line down like this. So this would be a straight line. So at H here, with the straight line, we'll have 180 degrees. And therefore, if I want this little angle inside of here, I'll put that in blue. This angle here, I would simply take away 180 degrees from this 228. So the 228 degrees take away 180 degrees is equal to All right, so we are 228, take away 1/8, and we get 48 degrees. All right, so this here is 48 degrees. That means inside of here is 48 degrees. So what we have here is a Z angle. This north line is parallel to this north line. And if we form our Z, here to here to here, therefore this angle here will also have to be 48 degrees because alternate angles are equal. And this angle represents the bearing of H from E. Let's just draw off this green line like this. Put a blue line. Clockwise direction, 48 degrees. So the bearing of H from E is equal to 48 degrees. So for part B of part 3, we want to find the bearing of G from H. So that's G from H. So we have the north line on H. And if we go in a clockwise direction to the line touching H to G, that would be the angle that we want, the bearing of G from H. So that angle will be this angle here in a clockwise direction. All right, so let's just draw this situation separately. Okay. All right, so I have my north line on H. I have this line connecting to E and this line connecting to G. Now remember that we have that the bearing of E from H is 228 degrees. So what we have is this whole angle here is 228 degrees. All right, so here is 228. Then we have this angle 54 degrees, which is angle EHG. So EHG is 54 degrees. So we put that in, 54 degrees. All right, that's from here to here. Then think about it. If this is the angle that we want, let's put that in green. So we want this angle here, in a clockwise direction from the north line. All we have to do is take away the 54 from the 228, and we get this angle here. So we're going to have the bearing of G from H is equal to 228 degrees take away 54 degrees, which is equal to, all right, 228 take away 54 degrees, and we get 174. So we have 174 degrees. All right, so here I'm going to write 174 degrees. And therefore here we also have that 174 degrees. All right, so my bearing of G from H is 174 degrees. So here we have in question 10 part A, in the diagram below, O is the origin. So O is the origin here. We have O to E is equal to 2 times E to F. So the distance from O to E is equal to 2 times the distance E to F. So this distance is twice this distance. Now, if you really think about that, from O to F would be a whole, and from O to E will be 2 parts. Let's write that in. So here will be 2 parts, and from E to F will be 1 part. And therefore, the whole thing from O to F will be 3 parts. Therefore, from O to E will be 2 out of 3 parts times OF. So 2/3 OF will be from O to E. And from E to F will be 1/3, 1 part out of 3 of O to F. So O to E will be equal to 2/3 O to F. And E to F will be equal to 1/3 O to F. Now let's keep reading. And M is the midpoint of EG. So M is in the middle of this line E to G. Therefore, E to M is half of E to G. And also, M to G is half of E to G. So let's going to write down that. From E to M, the vector E to M is equal to half the vector E to G, and the vector M to G is equal to half the vector E to G. And we have the vector O to G is C, so that's from O to G is the vector C, and the vector O to F, so O to F is D. Now we want to find in terms of C and D in its simplest form for part 1, the vector FG. So if you look at the vector FG, that's going to be our resultant vector. That's F to G. Let's highlight that. So that's the vector going from F to G, so the arrow is pointing towards G. So that means the head is at G and the tail is at F. Now we're going to use the triangle law here. Now seeing that we know the vector O to F, see, O to F is D, and we know the vector O to G is C, we will use this big triangle here. Now yes, I'm also seeing a smaller triangle here, but we don't have enough information to use this smaller triangle. But we have the information from O to F. So once you know O to F, you can get F to O. You know O to G, you can get G to O. So using this big triangle here. Now, we know if this is the resultant vector using the triangle law, the vector along this line O to F, the tail must connect to the tail of the resultant. Therefore, the tail of this vector is going to be at F and the head is going to be at O. Therefore, the vector will look like this. And now, for the vector along the line O to G, seeing that the head of the resultant vector is at G, therefore this vector, the head must also be at G. So seeing that the resultant vector, this vector here, the tail must connect to the tail of the resultant vector, and this vector here, the head must connect to the head of the resultant vector. So that vector will look like this, pointing towards G. So see that the head at G, tail at O. So therefore my vector FG, that's going to be equal to the vector F to O plus the vector O to G. So I'm going to write that out. F to O plus the vector O to G. Now notice how we have F first, then G last. See F, G, and the same letter in the middle, which is the O. So that's another little pattern you can look for when you're trying to find a resultant vector. So now we have O to F is D. Therefore, F to O will be negative OF. All right, so if O to F is D, then F to O will be negative D. So that's negative D. And of course, O to G is C. So what we're going to have is negative D plus C. So we're going to have negative OF, all right, but that'll be equal to FO, plus OG, and negative OF, that'll just be negative D, and OG is C. Now, sometimes, we don't like to write the negative one first, so you can write the positive C, then the negative D. So you can write negative D plus C, or you can write C take away D. And that will be my vector F to G. All right, now, so moving on to part 2, we want to find in terms of C and D in its simplest form, the vector E to G. So let's highlight that resultant vector. So that's from E to G. So the arrow is pointing like this towards G. So the head of my resultant vector is at G, and the tail of my resultant vector is at E. Now, I know the vector OF, and remember we know the ratio here. O to E is 2/3 O to F. So I know this vector here, and we know the vector O to G is C. Therefore, I can use this triangle right here to find my vector E to G. So now, the vector along the line O to E. Seeing that my resultant vector, the tail is at E, then the vector along this line, the tail needs to be at E, and therefore the head would be at O. So my arrow will point in this direction towards O. And then the vector along the line O to G to form the triangle. Since my head of my resultant vector is at G, the head of this vector must also be at G to connect to the head of the resultant, and therefore a tail will be at O. So that vector will go from O to G, and the arrow will point towards G. So you're seeing head of this vector connects to the head of my resultant, and the tail of this vector connects to the tail of the resultant. So therefore, the vector e to g would be e to o plus o to g. So my vector e to g is equal to e to o plus the vector o to g. So now remember, o to e was 2 times e to f. So o to e was 2 parts and e to f was 1 part. Because this distance is twice this distance. Therefore, the total distance is 3 parts. And the total distance will be from o to f. And remember we said, since this is 2 parts out of 3, this is 2/3 o to f. So again, I'm going to write o to e is 2/3 the vector o to f. Which will be, remember the vector o to f is d, so that's 2/3 d. Now, remember, we don't want to go from o to e. We want to go from e to o. So that has to be negative of the vector o to e. So therefore, e to o will be negative o to e, which would just be negative 2/3 d. All right, so this vector here will be negative 2/3 d. And of course, this vector from o to g is still the vector c. So what we're going to have is negative 2/3 d plus c will be our resultant vector e to g. All right, so e to g is equal to e to o, which is negative 2/3 d plus the vector o to g, which is c. Now again, if you don't want to write the negative first, we could put the positive c first and then the negative 2/3 d. So either one will do. That's the vector e to g. So next for part 3, again, we want to find in terms of c and d in its simplest form, the vector o to m. So that's o to m. Let's highlight that resultant vector. So this vector is pointing towards m, from o to m. Now, we have to decide on which triangle we're going to use, because we have this triangle up here, which we could use, because we know this vector from o to e. And remember, we said the vector e to m is just a half of the vector e to g, and we just found in part 2 the vector e to g. So we can use this triangle on top here. Or we can use this triangle below here, because we know from o to g is c, and again, from m to g is a half e to g. So any one would do. I just think it might be simpler to use this triangle down here, because here is just c, and then we just work out this vector here. So let's form our triangle. This is my resultant vector. The head is at m. Therefore, the vector along the line m to g, the head must connect to the head of the resultant vector. Therefore, the head must be at m. Therefore, the arrow will point in this direction towards m. So my resultant vector, the head is at m, and this vector here, the head connects to the head of the resultant vector. And therefore, this vector down here, the tail must connect to the tail of the resultant vector. So that vector is going to look like this. And the tail is going to be at O, so therefore it needs to point towards G. So the head is at G. So therefore, my vector from O to M will be the vector OG plus GM. All right, so my vector O to M is equal to O to G plus the vector G to M. So see, we have the vector OM, O first, then M. So we have O first here, and the last letter is M, and we have the same letter in the middle, which is G. So now O to G, that's just the vector C. All right, so that's just the vector C. Let's write that down here. Here's C. And now what we have to do is work out the vector G to M. So if you want to look at it, the vector G to M will be half of the vector G to E. So let's just work out that here. So we're going to have first the vector G to E, which will be negative EG. And remember, we found that vector EG. Let's go back here. EG is equal to C take away 2/3 D. So let's write that in. So that'll be equal to negative C take away 2/3 D. Now this negative out here is like -1. So if I multiply -1 by C, we're going to get negative C, and -1 by -2/3 D, that'll give you a positive 2/3 D. And that's my vector G to E. Now remember what I'm saying here is that GM will be half of GE. So GM is equal to half of the vector G to E. Therefore, that'll be a half of this vector here, negative C plus 2/3 D. And again, we could expand that. A half by negative C is negative a half C. And a half multiplied by 2/3 D, if you think about that, a half by 2/3, let's just write that right here. A half multiplied by 2/3. The 2's will cancel out each other, and therefore you remain with 1/3. Therefore, a half multiplied by positive 2/3 D will give you 1/3 D. So that's plus 1/3 D. And that's my vector G to M. So when I'm coming here now to write the vector G to M, I'm writing negative a half C. Okay, put plus negative a half C plus 1/3 D. So you're going to have plus, let's put that in brackets, negative a half C plus 1/3 D. Just going to erase this. Now this positive sign out here, that means positive 1. And if you multiply positive 1 by these two terms here, you just get back the same thing. So we're going to have C and positive 1 by negative a half C. We'll just give back negative a half C. And positive 1 by positive 1/3 D is just positive 1/3 D. So you see, let's come like here, drop the brackets and remove the positive sign here. So now these two are our like terms. So essentially what we are saying here is positive 1C take away a half C. So you want to think about it as 1 take away a half, which is just a half. So C take away a half C is just going to give you a half C. So this is just going to be equal to a half C plus 1/3 D. And that's my vector O to M. Now, if you're not sure about this part, you can go and work it out in a calculator. Just put 1 take away a half. But I think that's obvious to see. 1 take away a half is just a half. That's how I get the half here. If you want, I'll just put the 1 in red like this. So you can see it. 1C take away a half C. So 1 take away a half is just a half. And that's my answer for OM in its simplest form in terms of C and D. So now moving on to question 10 part B, we have the matrices P, Q, and R are given below. So we see that here, the matrix P, matrix Q, matrix R. So it's given below in terms of scalar constants A, B, and C. So you see within the matrix P, we have the scalar constant A. Within the matrix Q, we have the scalar constant B. And within this matrix R, we have the scalar constant C. So now we're saying that given that P plus Q is equal to R, find the value of A, B, and C. All right, so this is just equal matrices. All right, so let's set it up. P plus Q, that's equal to the matrix 3A, negative 9, 7, plus Q, which is this matrix here, negative 1, B, negative 4, 1. So it's just additional matrices here. Let's do a little shading. This 3 will line up with the negative 1. This negative 9 will line up with B. This A will line up with the negative 4. And this 7 will line up with this 1. So we're going to have this 3 plus negative 1. So that's this. Then we have negative 9 plus B. Negative 9 plus B. Then we're going to have A plus negative 4. So A plus negative 4. And then we're going to have 7 plus 1. 7 plus 1. So now let's just simplify as much as we could. The plus and negative sign here, we multiply it, so you'll get a negative sign. So this is just 3 take away 1, which is just 2. So we're going to get 2. Then this negative 9 plus B, we can't do anything with that, so we just write back the negative 9 plus B. Then we're going to have this A plus negative 4. So the plus and negative sign, you multiply them and you get a negative sign. So this is just A take away 4. So you're going to have A take away 4. And then 7 plus 1 is just 8. So this is my matrix P plus Q. So now we are saying that, P plus Q is equal to R. So P plus Q is equal to R. So that means this matrix 2, A take away 4, negative 9 plus B, and 8 is equal to matrix R, which is this C, negative 4, negative 3, 8. Now we are clearly seeing that this 2 is in the same position as the C. So that will mean C is equal to 2. So straight off, we can see that C is equal to 2. Then we are seeing that this negative 9 plus B is in the same position as this negative 3. Therefore, negative 9 plus B is equal to negative 3. I can solve that equation. So B is equal to negative 3, carry across the negative 9 to positive 9. Therefore, B is equal to, and this will just give you positive 6. So B is positive 6. Of course, this 8 is in the same position as this 8, so nothing to work out there. But the A take away 4 is in the same position as this negative 4. Therefore, A take away 4 is equal to negative 4. So we carry across this negative 4. We'll have A is equal to negative 4, and this goes across and turns positive 4. And of course, negative 4 plus 4 is just 0. So A is equal to 0. So in terms of our answer, if you want, you could go in alphabetical order. A is equal to 0. Then you could go with B. B is equal to 6. And C is equal to 2. So now moving on to question 10, part C. We want to solve the following pair of simultaneous equations using a matrix method. So first, let's write this pair of simultaneous equation in matrix form. So first we're going to have the coefficient matrix, which will be 5, negative 2, 2, 3. So 5, negative 2, 2, 3. These are the coefficients of, x and y for both equations. So 5, 5, negative 2, 2 from here, 2, positive 3, positive 3. Now, seeing that in our variables, x comes first, then y for both equations, all right, we're going to have x first, then y is equal to, and then we have the 44 and 10. Let's write as a column matrix, 44, 10. And this is our pair of simultaneous equations in matrix form. So, here will be A, so the coefficient matrix is A, we call this X, and we call this one here B. So what we want to do is get the inverse of this coefficient matrix. So that'll be inverse of A. Alright, so if the matrix A is equal to 5, 2, negative 2, 3, let's get the adjoint of A first. Adjoint of A is equal to, now this 5 and 3 here will be our leading diagonal. So what we want to do is interchange that. So 3 comes on top here and the 5 goes below. So see, interchange 5, 3, 3, 5. And then what we want to do is change the signs on the non-leading diagonal. So this negative 2 becomes positive and this 2 down here becomes negative. So we're going to have a positive 2 on top here and a negative 2 below here. Let's make the bracket cell better here. So now this is the adjoint of our coefficient matrix. Next, we want the determinant of the coefficient matrix. So I'm going to have the determinant of A is equal to the product of the leading diagonal, so 5 by 3. Take away the product of the non-leading diagonal, so that's 2 by negative 2. So that'll be equal to 5 by 3 is 15. Take away 2 by negative 2 is negative 4. These two negative signs give us a positive sign, so we have 15 plus 4, which is equal to 19. So the determinant of the matrix A, which is our coefficient matrix, is 19, and the adjoint of A is this matrix here. So my matrix A inverse is equal to 1 over the determinant of A multiplied by the adjoint of that matrix A. So that's equal to 1 over 19 multiplied by my adjoint, which is this matrix down here, 3, negative 2, 2, 5. So you can write that as 1 over 19, 3, negative 2, 2, 5. So now let's come back to this form where we have A times X is equal to B. So we're going to have the matrix A times the matrix X is equal to the matrix B. And what we want to do is multiply both sides of the equal sign by the inverse of this coefficient matrix, which is the inverse of A. So I'm going to have A inverse times A times the matrix X is equal to A inverse times the matrix B. Now the thing is, when you multiply a matrix by its inverse, you get the identity matrix. So A inverse times A is the identity matrix I. So you're going to have I times X is equal to A inverse times B. But the thing is, any matrix you multiply by the identity matrix, you're going to get back the same matrix. So the identity matrix by X will just get back X. So X is equal to A inverse times B. So what I'll do is go on the next page and continue. So remember, the matrix X is just the XY. A inverse is this matrix right here. And B is this matrix right here. All right, so let's put back the question so we can see the original two equations, these pair simultaneous equations. I have it in matrix form here, so you can see what is A, what is X, and what is B. This is A inverse. And remember what we had was a line here. All right, we had X was equal to A inverse times B. So X is the matrix XY, the column matrix XY. A inverse is the 1 over 19 times, you have this 3, negative 2, 2, 5, times the matrix B, which is the 44 and 10. So now let's do some matrix multiplication. You know, rows in the first matrix multiplied by columns in the second matrix. And you know the order of a matrix is in the form rows times columns. So this has 2 rows and 2 columns. So you know that this is a 2 by 2 matrix. And this matrix here has 2 rows and 1 column. So this is a 2 by 1 matrix. So once these inner numbers are the same, it means that these two matrices are compatible for multiplication. And the resultant matrix would be a 2 by 1 matrix. So that's the answer when you multiply these two. You'll get a 2 by 1 matrix, which is 2 rows, 1 column, which is going to be a column matrix. So you're going to have 1 over 19. This is our scale on the outside. And you know the answer is just going to have one number here and one number below here when you multiply these two matrices. All right, so let's highlight the rows in the first matrix times the columns in the second matrix. So for this top number here, this top row will control the answer for this top number. And since we just have one column, you'll be multiplying this row by this column to get the answer here. And since this is the second row, the second row here will control the answer for the second row. And since we only have one column, the second row times this column will give us the answer for down here. All right, so let's go. So 3 times 44, let's write out 3 times 44 plus 2 times 10. And then coming down here now, second row. So second row, only column, negative 2 times 44 plus 5 times 10. Close brackets. So let's recap on that. 3 times 44 plus 2 times 10. See that? Row by column. And then come down now, this row by this column, negative 2 times 44 plus 5 by 10. So let's work out that 3 times 44. So 3 times 44 is equal to 132. So you're going to have 1 over 19 by 132 plus 2 times 10, which is 20. Negative 2 times 44 is negative 88 plus 5 by 10 is 50. So that's 1 over 19 times 132 plus 20 is 152. And negative 88 plus 50, let's look at that. Negative 88 plus 50 is equal to negative 38. So we have negative 38. All right, so let's remember xy is equal to that. All right, so xy is equal to, so what we need to do is multiply this 1 over 19 by 152, which is simply dividing 152 by 19. Let's do that on the calculator. All right, so you can put, 1 over 19 like this and multiplied by 152. No problem doing it like that. And you get 8. Or you could just say, 152 divided by 19. And you still get 8. So we're going to have 8 on top here. And same thing, 1 over 19 multiplied by negative 38, or negative 38 divided by 19. All right, so negative 38 divided by 19, and we get negative 2. So we have negative 2. So therefore, if we compare positions, x is equal to 8, and y is equal to negative 2. And that will bring us to the end of this question 10, which is the last question in this past paper series. And this will be the end of the video.